Hello everybody, welcome back. It is another dev stream. Do y'all remember the last time we did one of these? Yeah, we're going to be doing another one today. It's going to be a good time. We're going to be working on my handmade game engine, Slate, which if you've been tuned into the last couple streams, I've not been able to stop yapping about. And I ran a poll recently. This stream was originally going to be working on a new Twitch chat for the streams. But in a poll between that and working on Slate, Slate won by a single vote. So we're gonna be doing that today. Let's see what's shaking. Let's see what's cracking. See what we're gonna get up to. Gonna be a good time. Gonna work on Slate. This ought to be fun. This ought to be very interesting because, like I said, I've not been able to stop yapping about this. Like, I'm so jazzed. I'm excited to actually work on this on stream because the last time I did it, I was on Streamplace before. It wasn't even on Twitch at the time. And let me think. We were just working on Vulcan stuff. Those VODs are available, by the way, over on youtube.com/@REMelodyLive. You can go see the stuff over there. I don't have the link immediately with me. I'm doing some new stuff with my Obsidian, so I closed my stream dock. Oops. But yeah, you can go there. youtube.com/@REMelodyLive. That's where you go. But yeah, how is everyone doing today? Let me say hi to everyone first before we start. Hello Retzinder, hello Lewis, hello Catgirl CEO, hello Upsample, hello Aquafoli, hello Julia. Anyone else down the list? Hello Emil Shaden, I hope I'm pronouncing that correctly. And I think that is everybody. Hello everyone. Good to be here. Good to be doing some dev work today, I suppose. A part of me really wants to make these like a regular staple, but at the same time, I don't know. If y'all are into that, I would be willing to do so. I only worry that, the gaming stuff is more interesting. I'd have to keep at least a balance of the two. That's what I would be doing. Right. So the plan for today... I'm going to start by just showing you where things are at the moment, and we'll kind of play it by ear from there. Like, maybe y'all want to see some particular kind of element going on. I'm cool, being a little bit selective based on whatever is the most interesting thing. Currently, the big focuses right now are the CPU, the software renderer, and a new audio engine that I started work on very recently, which I showed a little bit of at the end of last stream, which, by the way, kind of works now. Or at least it's nowhere near as broken as it used to be, which is, nice. Let's get right into it. So I do have a document over here on this screen. Here we are. Hold on. I got a bunny. Right, with the bunny out the way. So I do have I've made an entirely new Obsidian thing just for RE Melody stuff. Previously, I would just lean on my own personal notes, but I want to be able to have Obsidian on screen without potentially leaking sensitive information. So we have a dedicated vault just for this. This is basically just the README of Slate that I've copy pasted out of the README file. So yeah, the basic notes. So, for those of you who have no fucking clue what Slate is at all, Slate is a handmade game engine from almost scratch. Almost, because I do rely on a few small dependencies, and actually the README file in here actually does show. Yeah, we rely currently on SDL3, Vulkan utility libraries, just helps a lot with the Vulkan dev, and CGLM, which is our maths library. Actually, I should probably go into exactly what all these are, just in case there is anyone who doesn't know what's going on, but is very interested in following along. So, SDL3, SDL is the Simple Direct Media Layer, I believe. This is the third major edition of it, of course. And what SDL does, at least for me, in the capacity that I use it, it is really good for just establishing a window, like a context in the operating system that I can then draw pixels to, receive input from, send audio out from, in a nice cross-platform way. It provides all of the platform-specific abstractions, so I don't have to worry about writing window initialization code for Linux, and then for Windows, and then for Mac. Like, that would really suck to do, and SDL helps me a lot in doing that, and it's a really good bit of scaffolding for the earlier stages of this project. I'm not ruling out the possibility that I end up taking this out at some point and doing something entirely custom to make this even more handmade, but for the time being, 4 dependencies is not that bad. Vulkan, for anyone who is uninitiated on that, is a graphics programming interface, basically. It is a really good library for interfacing. Well, the Vulkan library lets me communicate over the Vulkan interface to my graphics card, and that lets me actually draw triangles on screen, the most famed primitive shape that all graphics cards are able to draw. So we'll be using Vulkan for the rendering side of things, including, I did mention, a software renderer that completely forgoes the GPU and actually goes straight to my CPU. It is a lot less performant, that's the cost, but the benefit is I get to be really goddamn intimate with exactly how the rendering happens, which it's mostly a thing I'm doing for the sake of learning. It's not necessarily something I actually intend to base a full project off of, but it is interesting. So, yeah. Vulkan utility library just helps me write Vulkan. Not a big deal. It's got like one helper function that I use a lot, but it's like a pretty big useful function, so it's nice to have. I think it's like translating error codes into actual error strings, and Vulkan has a lot of error codes, so I do not want to maintain that list myself, so I use this dependency. CGLM is a maths library that lets me do maths. It gives me vectors. It gives me dot multiplication functions. It gives me a whole bunch of really nice stuff that we will surely be seeing a lot of as I continue working on this project. Right. And I'll very quickly, just before I'll read chat in a moment. I will quickly just go over the base idea of the things that I do want to work on with this engine. So, to be clear, I kind of do have a game idea, but it's not something I was necessarily thinking of streaming. Slate is definitely more of a pet project for me, and I was thinking I would use Godot for anything super serious. But I have a renewed interest in this engine, and I've, through just looking around and learning, managed to demystify a lot of stuff that was way too intimidating for me in the past, to the point where I'm starting to think maybe I can build my own handmade engine with, the capacity available to me. To be clear, anyone can do this. It's just, do I have the time to do this? I think I can maybe make it work. It would be a long project, but I think it's doable. But yeah. As for the engine itself, which is the first most important thing, you need an engine to make a game. So, things I will implement myself. We're going to have rendering. I have my custom CPU rendering pipeline, of course. Let me turn down the music just slightly. Yeah. I do have the CPU rendering pipeline, but we do already have most of the Vulkan code written. It's not complete. There's no triangle on the screen yet with Vulkan, but we are very, very close. I just, over the 2 streams that I spent working on that, I didn't finish implementing all the things I needed in order to get a full thing initialized. But that could be very close up on the list. Input handling. I mentioned here, I did this before in a Rust-based version of Slate. You might be wondering, Ari, if you were building Slate in Rust, why the hell are you doing C? Because I find it more challenging and interesting. That's why. And also, there were a whole bunch of other weird things with the Rust build where it's like, yeah, it would have been better for me to kind of do it mostly from scratch. But I do want to steal the input handling API that I built for this. It is a really, really nice action system where I take in raw inputs, I bind them to actions, and so all I need to do on like the interactivity layer, if you want to call it that, is listen for those actions, like just pull them on updates. And this could be like, you know, it's pretty much just going to be like some number of scalar values is what I'm dealing with. So anything like 0 to 1, I think -1 to 1 maybe. I forget exactly how that interface worked, but that's something we could decide a bit later down the road. So for example, you wouldn't just listen for W, A, S, and D. What you do is you create a 2 scalar action called movement or whatever, or like a move action. And one scalar would be the x-axis, one scalar would be the y-axis. And then you would bind keys 2 points on those to that action. Sorry. So W, whenever that's pressed, will push up the move axis up along the y-axis. D will push along right on the x-axis. And then all I have to do is just listen for that vector. And then I can use that to process however I want the player to move. It's a little bit of extra work in the middle, but it provides such a nice interface for working with inputs. And it would also, in theory, make customizable inputs really, really easy to do. And also controller support. In fact, supporting a whole bunch of different input methods would be super easy with this API. So I'm very, very excited to re-implement that. For the time being, I am just listening to keyboard inputs, though. Networking. I really, really want to see how quickly I can get a multiplayer demo project with this done. Multiplayer is not easy, and that's kind of one of the reasons why I want to tackle this so early. I want to make sure that this thing is multiplayer capable, and I want it to be stable, and I just, you know, I want to get a whole lot of annoying cruft stuff out of the way so I can just make games around it. In-engine editor tools. I'm actually a little bit unsure of whether I want this to be an engine feature or a game feature, because I comment here that I really love the creativity that is employed in a whole bunch of custom, like bespoke editors, like level editors and whatnot. So I'm wondering, is that custom enough where I'd want to leave it to the end game developer to figure out what they want to do there? Or is that something that I'm actually comfortable building an engine? Not 1,000,000% sure yet. I might end up making the equivalent of like Hammer editor or some shit like that. It really depends. It also depends on exactly how I want worlds to be built. My main idea with Slate has been this would be a top-down 2D focused engine. So think the style of Pokemon or whatever, but I can put fancy shaders on it basically. But there's very little stopping me from making Slate 3D capable as well. So I'm like, I don't know. Yeah, kind of like a Trench Broom situation. I could probably just make it Trench Broom compatible, to be completely honest. That wouldn't be a terrible idea. I just like the self-sustainability of it all, you know? PNG support. I need to load textures at some point, and PNG is a dirt easy format to implement. I've read the Wikipedia article in like an hour. It's really not that big a deal. Especially parsing metadata, no problem. The image like data format itself, not that difficult. I don't know the exact intricacies of it, but I'm not expecting it to be difficult. WebP would be trickier. I will probably rely on libwebp for this for the time being, but if I could write a custom decoder for this, that would also be very cool. Of note, I would only be supporting lossless WebP. I'm not dealing with any any lossily compressed formats for the time being, except for maybe sound. And this is where this gets interesting. So I do want to support FLAC, because FLAC is also pretty simple. Well, as simple as audio decoding can be. So yeah, FLAC looks like it'll be the easiest of the audio formats to implement, but I would like to support Vorbis as well. But Vorbis is a lossy codec, and that introduces a lot of other things that I need to then handle. So it gets a little bit awkward. I was also saying that supporting Opus would be really, really funny. Mostly just to do voice chat. Because, I mean, I'm going to have networking probably by the time I've got, like, something properly fleshed out, right? Wouldn't it be so cool to have the game has its own handwritten voice chat? That would be so cool. I would enjoy that immensely. So that's the things that I am committed to, like, yeah, I want to implement these things. The things that I might do. Physics. I'm not thinking of making anything crazy. Just like simple 2D box collisions, maybe some basic gravity, momentum, velocity stuff. Like nothing super crazy. We'll see. We'll see. I think whatever physics engine I make, it's not going to be super fancy, and it's not going to be better than, like, I don't know, what's a big one? Havoc, I guess. I think Godot uses Bolt, or has the option for Bolt. I think it's called Bolt. Yeah, not saying it's going to be that good, but it would be nice to do something along these lines. And, you know, just learning more physics stuff. I mean, it's kind of like learning about rendering and audio, right? It's all the same, basically. It all ties together and, like, trying to map out reality in a computer, and that's really cool. Audio. This has been bumped from might to am currently doing, basically. So I'm thinking of changing this to be like system audio integrations, because currently that is what I'm using SDL for. But I am already, like I said, experimenting with audio synthesis. So, like, we're pretty damn close to me doing some funky shit. The trickier bits would be applying audio effects. Like, if I could do EQ, filtering, fancy shit like delay and reverb, that'd be really cool. And I could do some really powerful stuff with that. Also, like, physically modeled audio as well would be really cool. Even in a 2D game, like, physically modeled sound can give you some really, really good immersion. So I'm thinking that would be an extremely cool thing to embark on. Windowing. This is the number one thing I am hugely leaning on SDL for as a crutch, because supporting windowing cross-platform is kind of... Okay. It would be a loss of work, but it would be a one-off, which is one of the reasons why I'm not ruling this out. I would basically need to write pretty solid Windows, Mac, and Linux code once, and I am very unlikely to change it. As I understand it, Wayland is a pretty stable API at the moment. Mac will probably actually be the most difficult because they don't really support their Objective-C bindings anymore, as I understand it. But there's still enough there for me to make something work, I think. Windows just sucks. Windows just sucks in general. Win32 API is just a miserable bag of shit. Every single time I worked with it back when I was on Windows, development on Windows sucks. To be completely honest, Windows is at, like, the bottom of my list in terms of platform support. Number 1, want to support Linux. Number 2, want to support Mac. And number 3 is Windows. And I know, it's like, oh, Windows has such a big market. Yeah, it's moving to Linux, IMO. It's very much moving to Linux. And Windows is just a sucky development platform nowadays. Like, maybe it was really good way back when, but it is, like, hugely been superseded. It's a very, very rough experience doing, at least, like, C, right? Very rough experience doing C on Windows, and I just do not enjoy it. Also, I glanced at the documentation for Zig, because I'm thinking actually porting Slate to Zig could be a really interesting idea in the future. And I saw some of the install instructions for Windows for Zig, and I'm like, oh, I'm so glad I'm not on that platform anymore. Rough doing any language on Windows? Yeah, of course, yeah. And the very last thing is a math library. Yeah, maybe. I'm probably going to implement math functions as and when I absolutely need to, but for now, I would like to guarantee that my math heavy code actually works. I'm getting better at that stuff, but think of it this way. Even if I were to implement my own math library, it would not have nearly half of the optimizations that exist in established math libraries. So like we're talking SIMD, AVX 512. I have no fucking idea how to do that shit. And I don't know if it's going to benefit me that much necessarily learning how to do that for this project. When there are still very established, very lightweight math libraries, like math libraries are not doing that much. Like Vulkan is probably way bigger than a maths library. SDL is absolutely way bigger than a maths library. They provide their own math functions. So yeah, that is Slate conceptually. I know I'll pull that up in a moment, the actual software itself, once I have read through chat, because I've missed a whole bunch of stuff. Let's see. Katie Plasma, my beloved. Yeah, baby. I love this thing. I've considered using GNOME. So I have a laptop running Linux that does run GNOME, and I think it is very nice for a laptop form factor, but I'm really mixed on the idea of using it for desktop. There's just a lot of particular things that KDE Plasma does really, really well on the desktop that don't translate over to GNOME very well. So, yeah. Plasma, my beloved, for sure. SDL is a good idea if you want to support Wayland, because the RenderDoc graphics debugger does not support Vulkan on Wayland, so you'll lose any graphics debugging you have there. Oh, dear. Well, that's good to know. Vulkan on Wayland specifically. Oh my goodness. I forgot that was my raid sound. KMKO3, thank you so much for the raid. 6 viewers. Hello, everybody. Hello, raiders. How are y'all doing? In case you're brand new and haven't even read the title, I am working on my own handmade game engine in C. I was just going over a conceptual overview of everything. This is like the first time I've done it on stream in quite a while. It's in an early stage at the moment, but we're in a good position at the moment, so it is very exciting. I thought for a second I got clickbaited. You're searching for a boyfriend by playing Celeste. This is a valid strat. That's a very valid strat, to be honest. All right, let me quickly poke through the rest of chat here. Vulkan over 1,000 lines for a triangle. Yeah, but there's some good lines. Like I've looked over, like I've implemented half the stuff that Vulkan wants me to do. And like, yeah, it's a lot of work, but I got really intimate familiarity with like what goes on in a graphics pipeline. And I haven't even got a triangle on screen yet, so that's like really cool for learning, at least. What's your opinion on Pyrite 64? I think I've heard of it, but that's about it. I know of it by name. I don't know much about the engine itself. Rewrite it and see. Yeah, just start from scratch for fun. You fail because you can't talk. No. How long have you been cooking? How far back does this engine go? First commit I did in March. And I was doing a bunch of Vulkan stuff around this time. And then eventually August happened. Because I put this project down for quite a while. But yeah, I don't know. The stage that I'm at, if you're working at this consistently, you could probably get here in like a few weeks, tops. Yeah. This whole engine is basically me trying to just implement all of the things that I find neat about game engines in the order that I find them the most neat. That's basically what's happening right now. So it started with trying to get Vulkan support in there, and then I was like, no, let's do a software renderer. That would be fun. And as of late, I've been working on audio synthesis, which is a very normal thing to do. The thing is, the audio synthesis stuff does line me up amazingly well for loading in audio. Like the moment I have a FLAC decoder, because that is on the things I intend to implement list, the minute I have a FLAC decoder, I could just pipe that directly into my audio buffer and just play sounds, which is great. I can even do it with volume control very, very easily. It's very nice. Stuff with FFI. If you could remind me what FFI is, because I actually don't remember. Apologies. Will you just be raw dogging UDP? It's likely for the network stuff. It is likely I'll be raw dogging UDP. That'll be exciting. I've heard some people recommend ASIO, not the audio ASIO from Steinberg, asynchronous input-output, which is some... Oh, wait, no. No, yeah, that's what it was. I heard about it. It was interesting, but it is a C++ library, so it probably wouldn't work here. I guess we got similar issues yapping instead of typing code. Oh yeah, absolutely. This is going to take up like the first half hour of stream. We're at the 26-minute mark, at least my recording says so. Streaming, yeah, we're at the half hour mark. You're gonna be able to code to get here in a few weeks. Yes. And C, mind you. So like I've been writing software for a number of years. That experience helps me immensely in this project. Are Melody streams for balding 55-year-old middle managers? Are you using Vim over NVim? Oh no. Hold on. It's Alias, baby. I love NeoVim. NeoVim, my absolute beloved. Absolutely. Love NeoVim so much. I'm kind of back and forthing between recent chatters from Raiders and then the previous stuff that I have to catch up with. Hopefully I can get through this pretty quickly. Can I be evil and see you focus on audio because my own game engine already has everything you listed but anything to do with audio? That is my focus right now because audio is in a weird halfway state. Well, actually, no, it's like 90% done. But that's great because I get to show you most of the heavy lifting I've already done and then just fix the problem that I have and hopefully we can move on. So yeah, absolutely. Wayland seems annoying though because of client-side decorations. I've been told I just use libdecor and I'm good. I'm just hoping it's a lightweight library because, you know, the whole point of part of the point of this is I want to be really, really light on dependencies. So long as libdecor is a light library, I might be okay. Normally it's not doing things based on market anyway because we're not 55-year-old balding managers at mid-sized companies. Yeah, we're scrappy startup millennials and zoomers. Right. Awesome. Okay, I think I'm mostly caught up. Now let's just read the newer stuff. FFI is the ability to call functions from other languages. Oh, foreign function interface. I've never done that. Never in my life. I think the closest I've ever gone to that is I have built a dynamic library loader before. That was cool. It's like a very rough proof of concept of like a plugin system. Very, very neat. But that's not really FFI, is it? Like they were both written in C. It's just I'm calling it from C convention, I guess. Never heard of ASIO C++ in my life. Yeah, came by some video talking about it. So I was like, oh, this is interesting. Don't think I'd use it because it's too high level for my liking. I want to build my own abstractions and whatever, but yeah. Finished college this year and started learning 4 years ago. Still suck at it. Hey, it takes time. It takes time. I would not have liked to look... I would not like today to look at the code that I wrote 4 years into my programming journey. Absolutely not. When did I start? Oh boy, how long's a piece of string? I mean, shit, I was probably doing Scratch at like 11. I'm 24 now. It's been like 13 years. C is a more recent addition, but I mean, I was writing Java 14, 15? For game dev purposes, of course. So, you know, I got a bit of a head start, I think. Yeah. Started at 19 because I went to college. I guess I need another 10 years. Hey, look, no better time than the present, right? 24? I thought you were 30 plus. Why do I give that? Why do I give that impression? I just got unked by Raiders. It's so over for me. Is it because I use NeoVim? Is it because I'm writing C? It's because I'm writing C, isn't it? It must be. Yeah, it's the C. It's the C. I had a feeling it was the C. No, that's just because I'm a huge fucking nerd. Right, I have a simple build command here that realistically I should just have in like a build and run script, but whatever. I have terminal history for this. So let's have a gander at what exists in Slate right now. So This is a blank screen with SDL debug text. I do actually have a CPU renderer working in here. I just disabled it for the time. Let me maximize this because we are going to be doing some code very soon. Let me reintroduce the software renderer real quick because I disabled it to save on CPU cycles, which was very valuable while I was working on audio stuff. But here we are. We have a little box on screen. This is all drawn on my CPU. I believe the debug text here is actually hardware accelerated. This is just SDL stuff. I was experimenting with sine waves, as you can see here. We have a whole bunch of debug information. So, of course, we have Slate alpha version, ticks per second, frames per second, audio frames per second. These are basically in lockstep 99% of the time. Realistically, I don't actually need audio FPS because, again, they're just going to be hard linked with each other. Frame time, that is important. My budget for frame time is 16 milliseconds und exactly, because that would get me around 60 FPS, and I do not want to go lower than that, so I don't want to go higher than 60 milliseconds frame time. Tick time, I mean, yeah, it takes like no time at all. This is like so piss easy. Audio frame time, I actually will keep this here regardless, because knowing how long my audio processing takes, you know, if this takes too long, that's going to eat at my frame rate because it's all currently happening on the same thread, which is actually something I'd like to fix at some point. But I will need to figure out some sort of multi-threading abstraction that works cross-platform, because I'm pretty sure that's different across Mac, Linux, and Windows as well. Not ideal. Verts and triangles, that is this little box over here. That's what that represents. And audio note stuff. So if I press M on my keyboard, that activates MIDI mode, and I can go through a whole bunch of different octaves here, 0 through 8, and I can press 1 through 4 to select any of sine, triangle, saw, and square. So I get a whole bunch of different little sounds here. Now, I'm probably going to have to turn down the music here so I can actually demo this properly. Yeah, let's turn that like nice and quiet. Hopefully you can hear this. Let me see. Oh, wait, I turned off MIDI mode. Cool. You cannot hear that currently because the audio routing has decided it doesn't want to play my game through here. Why do you keep going to my text-to-speech sync? That is like never in my life where I want you to go. That is so absurd and baffling. Okay, let me plug this into primary audio. Maybe if I save this config, it'll actually stick to this now? I don't know, maybe. Anyway, you should now be able to hear this. That's a low bass note, baby. Except that's not what I want. For any of you who are in audio, audio note frequency, that is in hertz. That's 440 hertz. This is not a 440 hertz tone. Not even remotely. You probably can hear it. It's just your headphones aren't picking up that frequency. Apologies. I'll turn it up. Turn up the octaves. Also, Machiavellian Alloy. Hello, welcome, welcome. Oh shit, 460 follower goal. Let's go. Here we are. Oh, good heavens. Yeah, there it is. Yeah, this should be audible now. We can play little notes. Ain't that delightful? Except, again, like I said, this is absolutely not working properly. So if I go and pull up just a new thing here, let's look up audio tone generator. Yeah, they should be fine. Online tone generator, just something basic. Okay, maybe not this one, something more basic. There we go. Okay, 440 hertz on a sine wave is supposed to sound like this. Whereas mine sounds like this. So that's not right, even remotely. So that needs to be fixed. Let me just see here. Did it actually save that config now? Or okay, good. It's actually going through primary now. That's fantastic. So it's time to debug some audio code, everyone. Before I do that, let me get rid of these and tell you what, we'll shift these around. In case you're wondering, hey, why are you writing your fucking debug code across all these different lines? Well, that's because SDL's debug text function doesn't support new lines. It doesn't support Newline characters. It just renders nothing. Which isn't great, but they do say this is like not recommended for much of anything. This is really just debug text. So at some point I do intend on bolting on a font rendering system to this, and I actually have a pretty good idea on how I'm going to do that. Working off some existing code that I wrote many moons ago, but is still actually pretty solid. And I should be able to port it to the software renderer and the hardware renderer pretty easily, is the hope. Wow, a Kagi user? Yeah, I pay for Kagi. Family plan, baby. I only recently learned that NeoVim buffers can be integrated into Lua Line. I've been using Harpoon for years like a dummy. Oh, interesting. I am also using Harpoon. Maybe I gotta get into that. That's interesting. Ari, for the love of God, just use Harfbuzz. What the fuck did you just say to me? What does that mean? Did Armella just give a subliminal frame flash like the green McDonald's ad? Oh, me tabbing through this? No, you're fine. Harfbuzz? Oh, it's a text font library. Yeah, but I could also write my own. Right? To be clear, I'm not talking vector fonts. I'm talking bitmap fonts. I would probably use a library for vector fonts until I decide I'm bored of that and I would like to learn how to do that from scratch. Look, there's a good Sebastian Lake video on it. So I'm sure I'll be fine. Do you have no idea how complex Unicode is? I do have an idea. I'm scared. Kimi, okay. Gotta go. We'll see you someday. Have a good stream. Bye-bye. All right. Thank you so much for stopping by and thank you for the raid. I hope you have a lovely rest of your day. Do rest up. Fonts suck. They do, but it's a nice thing to conquer, right? A big idea with this engine is I don't want to be scared of anything, right? Like, every single thing that is running on my computer right now, someone built it at some point. Now, granted, it was across a lot of different people over a very long time, but I'm not implementing everything my computer does. I'm just implementing some of it. So, like, you know, if you're just rendering monospace English text, then rolling your own isn't that difficult. And that is what I was intending to do. Only rendering English is ableist/s. Thank goodness I read the /s at the end. Yeah, to be clear, yeah, I know it's not a perfect system. Font localization and all that would be a huge pain in the ass, but we'll burn that bridge when we come to it. If I'm able to render just like one of my system fonts, I'm golden. Like, I could not be in a better position at that point. That'd be so damn good. Right, let me make sure that debug text looks like I want. It does. It's nice and separated. That's pretty good. Okay, audio time. Remembering my binds because I'm actually still kind of new to this keyboard that I've got at the moment. Oh, I don't need AFPS anymore because we're not actually tracking that. Just audio frame time seconds. Right, so the schmeat of this is in our game loop. And all this does is, ignoring the kind of cruft around it, most of this is actually just tracking how long...
It's time to drink water.
How long it takes to drink water! Because it is time to drink water! Of course, yes. Everyone, you know the deal. It is time to drink water. If you have water with you, you should drink it. And if you don't have water, you should go get some, because water's good for you. Lovely water. Right. So, most of the code here is actually just tracking how long it takes to do, say, an update or a render or an audio update. But the actual functions themselves, we have our update function, we have our render function, and we have Slate Audio Synth Update. And that is our own custom audio engine's update function. To do audio processing has to go in its own thread. Doing this with rendering absolutely cooks the buffer. Well, not necessarily, but let's say audio processing should go on its own thread. I found that this does actually kind of work without that. Like, synthesizing a single sine wave is not that computationally expensive. It can very much fit within our frame budget, but it should be on its own thread for a couple of reasons. So, the basics of how the audio loop works. First thing we do, so we end up pushing all of this audio into SDL's buffer. And the first thing that we want to do is we actually want to see how much is currently in STL's buffer and make sure that, what is it? Only buffer more audio when there's less than one full buffer left, basically. In this case, the buffer size that I have set is, I think, 512 samples? Yeah. So we're at a sample rate of 48 kilohertz with a buffer size of 512 samples. So what that means is we take 512 changes in amplitude, basically, at a time. And we basically, this is how pretty much all audio processing works, as I understand it. You basically render, for lack of a better term, your audio for that very brief, I mean, like 512 samples. Like if we do 512 over 48,000, another Ash! Oh my god, Space Ashes! Oh my goodness! Been a while. Hello, thank you for the raid with 4. Thank you so much, appreciate it. How's your stream? How's it been going? 2 raids in a single stream, that's new. Hello, raiders. Hope you've been having a good day. Good stream? Hell yeah, hell yeah. Dev streaming does wonders. Fucking apparently, people want to know. Right, I was talking about how small my buffer size is in terms of like time. Yeah, if I do 512 over 48,000, that's the amount of seconds that this update function is rendering out. It's like 1 millisecond of audio. When you consider that monitor response times, or at least my monitor's response time, is around a millisecond, there is absolutely no problem with the buffer size of this length. And frankly, if I really cared, I could probably bring this down to like 256 or even 128. It depends on how expensive the audio processing is. The more expensive it is, the more I may need to buffer, basically. It's when I start running into buffer underruns is when I would want to increase it. I don't see that happening anytime soon. So Luna, hello, welcome. No shame in having a small buffer size. Of course. All buffer sizes are valid, except 0. That doesn't make sense. Right. So this audio function, first thing we do is we grab, get silence value for format. In this case, all of our audio is in signed 32-bit little endian. So essentially all that means is I take a 32-bit integer that's somewhere from, God, what is in 32 max? Yeah, so between this number and negative this number, and I dump whatever that value is into the buffer with like at each sample slot, and then SDL pushes that out, and then we make sounds happen. I should probably make, I really don't want to use like magic words here. Make sounds happen. What I mean by that, so if you think of it this way, for any of you who did like physics in high school, secondary school, whatever, the way that sound is made is there's some displacement of air, right? This is a very simple concept. There's displacements of air, and what, say, a speaker driver or the drivers in your headphones are doing is they're just pushing a diaphragm back and forth. And what I'm essentially pushing into this buffer is where I want the driver to be. So if I'm making, say, a sine wave, I'm telling the system, hey, please push the diaphragm like slowly up and then slowly down and then back up again, and just oscillating back and forth. That's basically what I'm doing. Now, in terms of this buffer size, I think this maybe fits like, I don't know, a small handful of sine waves at most. It's really not that much. But of course, we're going to buffer a lot of these really quickly because we have the CPU budget to do so. Yeah, all we're doing is just telling the system, hey, please move the diaphragm here. And of course, with audio mixing and stuff, like the music playing in my headphones, it's going to mix those together. So computer is breathing very quick. Kind of deal? Yeah, pretty much. This is what it's doing all the time. And what's neat is like when you demystify that, right? Where it says like, oh shit, okay, so a single audio sample of which 48,000 exist in a single second, at least for my configuration, right? all I'm doing is telling the computer, please push the diaphragm to here. That's it. And it's really, really cool when you figure that out, because then you can then do crazy shit like, synthesize your own audio, or, reading PCM audio like a WAV file, right? Becomes very simple in concept. Like, all I'm generating PCM audio right now is essentially all I'm doing. A WAV file would just be, I parse the header metadata, and then I just dump its contents into my buffer, and boom, I've played sound. But I don't want to support WAV because WAV is kind of stupid. It's very simple, but it's stupid. I really, really would like to support FLAC because I don't want to actually just dump uncompressed audio into people's computers when I ship games with this. What about a buffer size of uint64 max? So I would, except think of it this way. Most audio that you listen to is going to be like 16 to 24 bits, and that's on like the high end of audio, right? 16 to 24-bit audio. Basically, nobody does 32-bit audio. My professional DAW that I spent like good money on doesn't do 32-bit audio. It does up to 24. But 24 bits is not really a convenience data type for a computer to work with, most computers anyways. So I just rounded up to signed 32. There is basically no signed 64 or unsigned, or sorry, wait, was it? Yeah, uint 64 max. Oh, sorry, you're talking about buffer size. Oh my God, not bit depth. Oh, I totally misunderstood. So I could have a buffer that long. Here's the problem though. uint 64 max would be, let's see here. uint64 max is going to be this. So let's take that. Let's copy that. And we're going to just, rather than 512, we're going to do that divided by that. Cool. So we'd have to wait. Let's see, that's in seconds. So let's do minutes, hours, days, weeks, years. Yeah, so if you're cool waiting for about 12 million years for the sound to play, because that's how long it would take for the buffer to fill, sure, we can do that. I'd also run out of memory immediately, so I'm probably not going to do that. I think the reason we have 64-bit systems is because we will theoretically not reach the 64-bit integer limit in our, like, system memory for like hundreds, if not thousands of years. And at that point, we have other problems to deal with, so whatever. Right, okay. All that just to explain the basics of how we generate sound on a computer and what the buffer does, basically. Let's talk about actually synthesizing the sound. So, we establish our buffer. First off, it is an assigned 32-bit integer array of buffer size. This is set at runtime, but again, mine happens to be 512. So you have 512 samples that we can play with here. So then we loop through every single sample in that slot. We default to silence, I believe. Oh yeah, that's if frequency is 0 and amplitude is 0. Don't worry about that, that's fine. Ignore this to do. We talked about this in a moment, but we talked about this earlier. We'll fix it in a moment. Cool, so we're going into our buffer, and now we need to decide what we want to put into each slot in our buffer. Where do we start? We need to get a time value, because oscillation is over time, right? You can't just do a sine wave. You have to do a sine wave over time. So this is what does that. And in this case, we calculate time as a measure of our sample index divided by our sample rate. So, the very, very first sample that we render at all is just going to be a time value of 0. But if we're, say, a full second into playing this sine wave, the sample rate being 48,000, sample index would be like 48,000. So by the time we have reached 1 second, we will have completed 48,000 samples of a sine wave in this case. So then we switch over whatever our configured synth shape is. I'll probably change this to being something else, like, you know, having custom waveforms would be really cool. I could basically just support MIDI and make a built-in tracker. That'd be really, really cool. A MIDI tracker. But for the time being, I have set oscillator functions that I will switch through. So if it is sine, we will use the sine oscillator. Triangle is triangle, saw is saw, square is square. Pretty simple. We get whatever the sample is at that time with that frequency, and then we multiply by amplitude. So that's our volume control, is the amplitude. And then we multiply by int32 max. This is only done just to massage it into the formats that we've provided to SDL, because otherwise this would be a float 64, which SDL does support. Like, we technically don't have to do that multiplication. Maybe it would be easier. Like they do, yeah, SDL audio F32. So we don't have F64, notably, because again, bit depth basically caps out at 24 for 99% of cases, right? But the reason I'm keeping Sine32 little endian is because we're probably not going to do audio synthesis that often. We're likely going to be doing like loading audio and maybe manipulating it in that space. So it doesn't make that much sense to switch the format for that reason. And in this case, we can work perfectly fine in a float 64 environment and then just cast it into int32. It's not a big deal. I've tested back and forth what it actually sounds like if I switch to using float 32 as a baseline. It doesn't sound any different. It's imperceptible. Like, this cast is pretty accurate. It's not going to have problems. Yep, so we run through the oscillator function. We load into our sample buffer, whatever our current sample is. Again, cast it to int32. That's very important. And then we increment our sample index. This part's a little bit awkward. So the thing is, sample index, it does get set to 0 whenever I press down a new note. But there is an edge case where if you held down a note for a really, really long time, you might start introducing some weird floating point precision artifacts. It's very unlikely to happen very soon with a 64-bit float, but it's not out of the question. And that's just something to be concerned about. This mod here this modulo was supposed to clamp it within a certain range, but I found that if I just modded it off sample rates, basically every single second, the sample would just reset back to 0. And that's not good. That's really bad. There's maybe some fancier math that I can do there, but yeah, for the time being, probably best not to fuck with it. Just for now. I am getting some ideas on how I might be able to fix it. But again, it's such an edge case issue. It would probably require you to hold down a note for like many, many hours. That's not going to be a problem, I don't think. Because this is just supposed to be playing like little like chiptune notes, right? I think it's okay. Okay, let's get into the actual functions here. These are... Okay, forgive me for saying straightforward. So the sine and triangle are straightforward. Saw and square are not, just off the functions here, but the principles are very straightforward. So let me actually pull up... I would want Desmos graphic calculator. And let's go wave synthesis and Fourier series, because I already have this loaded. Here it is. This is a thing that I have been playing around with. And actually, you know what? I hope this works for y'all. I'll drop a link to this if you want to experiment with this and play with it yourselves. So this is basically just a graph simulation of exactly what these functions are doing. So we have our frequency. So we can adjust this. Higher frequency means shorter waves. If you oscillate faster, the pitch is higher. And if you decrease the frequency, then of course the waves get bigger. That is like fundamental, just working with sound functions. We'll start with the basic. This is a sine wave, or more specifically, according to Wikipedia, a sinusoid, which is a sine with specific temporal properties. And in this case, yes, it would be... I should probably scale this up a bit. This is the sine of 2 pi. This part is important. by x, which in this case is just a representation of time, by frequency. So the sine of frequency by time by 2 pi, and then multiply by amplitude, because of course, we want to play with amplitude. This should probably be from like 0 to 1. There we go, that's a bit better. Yeah, so you can play around with the amplitude and you can see it makes it quieter or louder. Very simple, very, very straightforward. The sine is the easiest thing that you could do with an audio synthesizer. It is so, so easy. Technically, a square wave would be easier, but for reasons I will explain in a moment, the way I'm doing it is not, and that's a good thing. We'll put it that way. So, the next one is the triangle wave. This is, as you can see, very closely related to the sine wave. It even uses a part of the same function. We literally just take that sine 2 pi xf and we put it in here, sine 2 pi xf. But we wrap it in an arc sine. Now, I don't know enough about what arc sine does. I just barely understand what sine does. All you need to know is that arc sine is necessary in the construction of a triangle wave. And we multiply all of that by 2 over pi, and then multiply by a again to get our amplitude. That is how the triangle works. Is an arc sine the inverse of sine? Maybe it is. Yeah, maybe. Arc sine. Inverse, trigonometric functions. Okay, well, that's giving me a clue. You have sine and... Okay, it doesn't say there. For circle of radius 1, arcsine and arccos are the lengths of actual arcs determined by the quantities in question. Fascinating. Cool. Well, yeah, exactly how it applies this triangle function, all I know is that we plug in our sine wave as the function to that, basically. So, I'll move on to the next one. This is the saw wave. This one gets a little bit more complicated, and by that I mean a bit. Now, don't be intimidated by this shape. This the sigma notation, I believe. Sigmoid? I think that's the name of the character. Yeah, don't be intimidated by the sigmoid. I used to be intimidated by the sigmoid. This is a for loop. That's all this is. This is a fucking for loop. Like, we start with... Okay, hold on. I will literally show you. This is a for loop. So, okay. Here we are. You can see we have S. In this case, S is... I think that's just arbitrary letter I used for, like, samples. I'll show you how this influences everything in a moment. We start with K, which is equal to 1, and then for every value of K until it reaches S, in this case, S is 256 in my code, we increment by 1. Well, we increment by 1 in the code because, you know, we can't deal with infinite numbers in computing, but we can deal with infinite gaps in between in the realm of mathematics. So it does actually work here, but this works perfectly fine as well. Again, don't be intimidated. So it's just a for loop. For every value of K between 1 and S, we do minus 1 to the power of K, all divided by K, and then, hey, look, that looks a lot like our sine function again, doesn't it? We multiply it by this again, except we introduce K as a little artifact in here. And keep in mind, K is our iterator value, so this is something that's increasing a whole bunch of times, and we're summing all of these different permutations of this function with K involved. And then, much like with the triangle, multiply by, in this case, minus 2 over pi, and multiply by A for our amplitude again. In the basics of what this is doing right now is we are generating a whole bunch of sine waves and then stacking them together. So you'll note that, like, you know, a perfect saw wave would just be a line from here to there, and then down, and then up again. Like, that would be a perfect saw wave. But here's the thing, and this is going to explain a little bit why the square wave is going to be so much more complex as well. in the realm of real world physics, you kind of can't just instantly push a drive back in a speaker driver back in a direction. What's likely going to happen is you're going to burn out the speaker driver by pushing it too hard. It's not realistic, and frankly, just in general, it's just not going to work. You need extremely finely tuned drivers in order to get anywhere close to a perfect saw wave, and even then you are going to be off by some minuscule amount, but that's okay. What the speaker driver does is it oscillates back and forth. It's going to wobble a bit, and what we're doing here is, in the digital space, we're basically introducing that natural wobble. We could be lazy and just make it a perfect saw, but it wouldn't be accurate to like a real synthesizer, like an analog synthesizer. And yeah, we've gotten to the point now where I'm now going to talk about the superiority of analog over digital synthesis. Look what we have to do to mimic a fraction of their power is basically what I'm saying here. This is not computationally cheap. I actually do want to look into writing a more optimized version of this. I think fast Fourier transform will help immensely with this, but I haven't looked into that yet, and this is performant enough, so I'm going to ignore it for now. But that is the gist of the saw wave. We are drawing just like going up and then down, going up and then down over and over again. But we're doing it with a whole bunch of constructed and stacked sine waves. And also, just as an idea here, this is like underpinning so much of computer audio. Basically, is Fourier transforms. Basically, Fourier transform. Hopefully, I can find something good here. In mathematics, the Fourier transform is an integral transform that takes a function as input and outs another function. Okay, no, this definition sucks. There's a theory behind this, basically. Knowing how these math concepts are is probably made up by some guy called Fourier or whatever. Here we are. Yes, in 1882, Joseph Fourier, claimed that any function, whether continuous or discontinuous, can be expanded into a series of sines. This, by the way, is the fundamental underpinning of most computer audio synthesis, and certainly most computer audio compression. So the way you're listening to this stream right now is very unlikely to be raw 32-bit PCM audio. What you're more than likely hearing is that PCM audio that has then been encoded into a whole shitload of sine waves, blasted over the airways, because here's the thing, the sine waves are much, much easier to carry over, like the parameters for all those sine waves are so much easier to carry over the internet than raw audio. There's a reason why we do this kind of compression. And then you receive it on your end, your computer will decode all of that sine information and will then generate the sine waves based on those parameters. That is how you are hearing me right now. So it is a very, very important function in the realm of computer audio. And in this case, we are doing that to emulate a saw wave. Everything uses Fourier transforms these days. All wireless networking is based off them. Yeah. It is, isn't it? That's not a thing I've looked into just yet, but no, that does make sense. Because, at that rate, you're basically blasting the equivalent of dial-up just very, very quickly and over radio frequencies instead of audio frequencies, right? Like, that's it. That's the whole deal. Anyways, so with those, I'm gonna mute these ones. I'm gonna hide them so we can show the square wave. Now, after everything that I just explained about the saw wave, this should be pretty intuitive at this point. It's just a slightly different formula. Again, for this series, k equals 1 until it reaches s. We do a slightly different situation here. We're not really... We are using the sine function, but we are using it differently. Actually, wait, no, it's not that different. No, it's actually really, really close. We're doing slightly different stuff with k in this case. You know, with the saw wave, we wanted something that increases a bunch and then drops. In this case, with the square wave, we want something that's all the way up or all the way down. And we're doing that by, again, stacking a whole bunch of sine waves together. This is a square wave. If you have ever seen an oscilloscope reading pulse width modulated signals, so like binary digital signals, you are almost certainly looking at square waves with these weird little points at the end and little wobbles and stuff. This is a very natural artifact of doing stuff in the real world with electricity. It wobbles. It comes and goes. It tapers. It has weird spikes and stuff. There is no perfect simulation. Well, there's perfect simulation, sure, but there is no perfect environment where you're going to actually get just a perfect square wave. So again, much like with the saw wave, we are emulating it using a whole bunch of sine waves. So if I were to increase S here, I haven't, because this is actually like probably the easiest way to actually render this out. But if we were to match our value here in code of 256, let's do this and just increase that. You can see if I zoom in here, so we started at around 50. And if we increase this, we just get more precision. That's all we're doing. We're increasing the amount of care and attention and detail we are giving this square wave. And you can see this also affects our saw wave too. It's even more precise than we had it before. It still has the weird spikes. Very little we can do about that. But that is the gist. If I were to decrease this, by the way, because this is also pretty cool. So we go back to 50, and then we even drop it lower than that. You can say we get like a really, really low fidelity square wave. At this point, this isn't going to sound that much different from just a sine wave with some extra harmonics or overtones over it. That's pretty much all that's going to happen there. But yeah, that is a, as brief as I can, explanation of how this kind of audio synthesis stuff works. I should note, I'm learning all of this stuff very, very fucking recently. I mean, I've had some precursor knowledge that I've picked up over time, but this is like the first time I've ever actually collected it all together and actually started applying it. We are doing audio synthesis from first principles, is what we're doing right now. We're doing it from the bare bones mathematics. I have another cool visualizer here, by the way, in case you're curious. If I toggle this one on, this simulates the accuracy that we'll get with our samples based on bit depth. So keep in mind, this is 8. We're currently doing 32-bit audio at the moment. For it to actually bring it up to 32, you're probably not going to notice the difference here. This is why it's like perfectly passable for a lot of people to upload 16-bit audio, because again, can you see the difference? Maybe you'll hear the difference ever so slightly, but it is not going to be much, and you want to be a huge audiophile to pick up that detail. But by the moment I go up to 24, which is what I tend to render my stuff in, I mean, did you see a difference? Short of me just pushing this along, did you really see a difference? If you're saying yes, you're lying. Yeah, if we go down to 8, this is actually perceptible. And then at this point, like, you just start shredding the audio. Like, it gets real bad at this point. At a certain point, you just hit like buzzer speaker levels of bit rate. It's pretty nasty. But yeah, that is a crash course on computer audio. Hope you enjoyed. With that said, we are an hour into this and we haven't written any code, but you now should understand how audio works in this context at least, and how I do it in Slate. It's not the most performant, but it is from first principles. I've learned a lot doing it, and it does work. Except the tuning. Now this is a tricky problem. I don't know exactly what's gone wrong here. All the math does check out, but the math checked out before and I was still having some weird issues. Granted, it was also unrelated to the math. That weird clipping issue that I had that I showed yesterday, that was an issue with how I was pushing stuff into my buffer. So I was filling the buffer perfectly fine with this code here. The problem is when I actually put it into SDL, I gave it... Whoops, let's put that back there. I essentially said, okay, hey, SDL, take this SDL stream, take my bank of samples, and here's the amount of samples that I have. And I thought that that was fine, except it is not, because if I go into the documentation for put audio stream data, we can read here, Your parameter length, the last parameter. The number...
It's time to drink water. It's time to drink water.
Okay, you got me. Yes, it is time to drink water, everybody. You know the deal. If you have water with you, you should drink it. And if you don't have water, you should go get some, because water's good for you. Oh, hell yeah. I love water. Right. So, the length parameter, the number of bytes to write to the stream. Now, pop quiz, everyone. What's wrong with that? What's wrong with me just saying, well, I've got this much buffer size, right? I'm not actually going to wait for chat. The problem with this code is that the buffer size does not represent the number of bytes. It represents the number of samples. And a byte is 8 bits, and I'm giving it 32-bit audio. So I'm essentially telling SDL to only take a quarter of the data I'm actually providing, because 8 is a quarter of 32. So I had to introduce size of in 32T, because that actually says, hey, not like this number of samples multiplied by the number of bytes in a 32-bit integer, which is 4. In fact, I think I can... Whoops. If I go size of, does it tell me? I guess it kind of doesn't, does it? Okay, well, I know on it's an int 32T. It's 32 bits, which is 4 bytes. So that solved that problem for us. Now, as for the tuning, I'm not 1,000,000% sure what the problem is here. So if I go back to, I closed it, didn't I? New window. Desmos calculator, thank you. Here we are. So the math checks out. It's sine of 2 pi by time by frequency. I have this backwards, but it's sine time by frequency by, this is just 2 by pi. Or sorry, that's... Wait. 2 divided by pi? Uh-oh. Did I just figure out what the problem is? Was that it? I think I was doing the wrong pi. Are any of these 2 over pi? Okay, the triangle one is 2 over pi. Oh. Oh, that was totally it, wasn't it? Hey, May, remember you were trying to figure this out last night? Cool. The math checks out. My ass. Okay, and then on the square wave, that's 2 pi. Yeah, so we do this. Okay, very funny. Let's see. Oh dear, what happened there? Oh, audio FPS. We still reference that? Oh, right. No, it's in slate.c because we initialized that. Yeah, we do. That's fine. Cool, let's try again. I'm delighted. Is that going faster than before? Oh my god, it is, because I'm using the oscillator function. I'm not using the sine wave, I'm using an oscillator. Where's that Wii text? I need to slow that the fuck down. That renders down here, I think? Oscillator sine, that's, I guess frequency 1. We want it to be 1 hertz. Yep. Oops. You're dying for that? Ooh. It doesn't sound very happy. Fascinating. That clicking doesn't happen with the square wave, so I don't think it's a buffer issue. That could be a... Ooh, that could be a precision issue, maybe? Triangle sounds okay. Oh. Okay. So those ones are not good. Those ones are not good at all. And I recall those sounding better before, so I need to double check my math here. That's 2 over pi. That's 4 over pi. Yeah. And then that's just... Yeah, shape factor, that's... K, yeah, 2k minus 1. Yeah. Why are you so unhappy? That's a weird one, isn't it? Could it be this? Because I know, oh my god, where did I just go? I know C can be a little bit weird if you're multiplying doubles by, well, I mean, that is basically an int, right? I think I need to be very explicit. Yeah, that's not good. That's not very good at all. Okay. That's gonna be fun to figure out. Oh yeah, please do let me know if the sounds are too loud, by the way. I can turn them down. I definitely don't want to hurt anyone's ears with this. Okay, so it was not that problem. Maybe there's a more optimal way I can do this that reduces the chances of... Yeah, these all multiply together anyways. Like, it's gonna be what it's gonna be. 1 over 2k minus 1 by the sine of... Well, like, okay, yeah. We get a square. It's just a very choppy square. So... Yeah. Funky one, that. You know what? Hold on. Oops. Let's just do like... We'll start with 256.0. And we're going to do this. We're going to make it a constant because I could see myself wanting to change this a couple times. I just want to make sure I know what I'm doing. Cool. Let's just turn down the resolution because, I don't know, maybe we're doing too much. Maybe we're asking the computer to do too much. That's definitely more stable. Okay, let's try 100. Whoops. Okay, yeah. So it was a resolution problem. I'm doing way too much. Is the issue? I could probably bring this like 64, maybe. And that'd probably make it like as clean as I can get. Nah, we still run into issues sometimes. So I'm gonna leave it at 100. And what I'm gonna do is I'm gonna save multi-threading that for another time because I really don't want to dick around with that right now. I do think the multi-threading this would solve that problem though, and I could probably even then turn the resolution back up. Or I do fast Fourier transform, because that would probably also solve this problem. Yeah, that's the thing. I don't really understand fast Fourier transform. I don't know. Maybe there's just an equation that I could just pull from. Fast Fourier transform is an algorithm that computes the discrete Fourier transform, or its inverse, IDFT, of a sequence. A Fourier transform converts a signal from its original domain, often time or space, to a representation in the frequency domain, and vice versa. Okay. Do we have just a function that I can pull? Ah! Okay, let these be complex numbers. Sure. DFT is defined by the formula this. Okay. Okay. Well, I see 2 pi. I see... Oh, k is over there now. Okay, m is our iterator. To n minus 1. Right, for every value from, I guess, 0 to 100 in this case. Or 0 to 99, technically. Okay. And that would be... Oh, I see. Gotcha. So, yeah, whatever our k is in this case, multiplied by e imaginary 2 pi divided by n, where that is a primitive nth root of 1. That's just gonna... Oh, okay. Nth root of 1. I mean, for what it's worth, this does actually look a lot less computationally expensive than the square function. But is that going to get me a square, though? Could you turn up the evil square? So I actually used to have a problem where... Actually, hold on. Tell you what. Let me do something cool. You'll like this. We were experimenting with this the other night. So this is Minimeters. This is an amazing... It's not free, unfortunately, but it's fucking worth the money. An amazing tool for visualizing a whole bunch of stuff. Let me actually show you how it normally looks like here. It is currently showing my music playing. Don't mind that. Stick to top. There we are. So it sticks up there. Let me just turn on all of the things. This is like just a whole hodgepodge of like every single music visualization thing I might want. It does spectrogram. It does waveform. It does LUFS. It does stereo analysis. I mean, what more could you need, right? It's so good. And of course it has an oscilloscope, which is the important thing in this case that I like really, really care about. So if I actually pull this over here, I think that's pinned to top. It is not, so let me pin it to top. There we go. And if I actually open Slate again and I play a note, let me pause the music here for this. Would you look at that? Hold on. And put it here so you can see it. That's a perfect sine wave. That's a low sine wave. You got a triangle. Or saw. Yeah, you can see it's breaking up a little bit here. It might be buffer underrun. Oh god, wait, yeah, look at the audio frame time. Oh, we're way out of budget. Yeah, I was right. It's too expensive. That's what it is. You got a square. Thankfully, less expensive than the saw, which I'm actually surprised by. Is the wiggling bad on a high note? What, this? Oh, the fact that it jiggles ever so slightly? No. So what Minimeters is trying to do here is it's trying to... Okay. The default function here is it will show, like, multiple cycles. You can see how it slides across from right to left. If I set it to single, what it tries to do... Here we are. Okay, no, it doesn't really tell me what that is right now. Essentially, what it's trying to do on single, yeah, it's trying to find 2 0 points, so where it's perfectly horizontal, and it will isolate to those points. So the wiggling that you're seeing is just it kind of struggling to find those 0 points, which is, you know, that's very normal for an oscilloscope. Nothing's perfect. Yeah, we got our sine, we got our triangle, our saw wave, which is very expensive, and our square wave, which is a little less expensive. For what it's worth, that sounds like a pretty high fidelity square to me. What if I drop this down to like 50? You know, like what we have in our visual in Desmos. Let's find out. It still sounds pretty nice. It's arguably a little less harsh because it's not flinging back and forth quite as often. If I switch this to a saw. Well, we do this well in budget, which is fantastic. I think if I shortened the buffer length, I would still have problems once again. And the thing is, here's something to keep in mind. This is important. The bigger the buffer size, the more latency. So long as I keep it in like a 1 millisecond budget, I'm probably going to be fine. But it's generally advisable. Like if you can get your buffer size down, that's good because that means less latency, which means people get to experience whatever it is you're trying to show them faster. Exact same thing goes for frame times in games. But that is pretty stable. Well, yeah, it's pretty stable. I can definitely work with that. It does sound weird on the lower frequencies, and that's another thing, actually. So the lower the frequency, the more obvious these weird artifacts, the inaccuracies are going to be. The more it's going to sound like it's, well, a warbly fart, I guess. Because, again, we're just doing sine waves. We're taking this soft sound, and we're making it do shit like this, is basically what we're doing, which is not very noticeable at these higher frequencies, because it's playing so quickly. But when we start playing it really slow... Okay, well that just sounds weird in general. There we are. If we play like this note's more reasonable. All of these artifacts become stretched. And keep in mind, each octave, we're actually doubling frequency. You can see there, 32, a bit over 64, 130, 261... Like, we're doubling the frequency each time. So every time we go up an octave, every time we go down an octave, we are maximizing the visibility of these inaccuracies by a factor of 2 each time. So that is something important to keep in mind with stuff like this. Like, I don't know, maybe you would want oscillator resolution to be higher at lower frequencies, I guess. But that's... I don't know. Would I want to do that? Not really sure. It's an interesting idea. Does Nyquist cutoff apply here? So unfortunately, I don't know enough about that part just yet. Anything that has the word Nyquist, I generally don't understand it. May actually knows a lot more about that than I do. She has studied a bit more of this than I have. I don't know if she necessarily subscribed to this from study. Actually, no, I think maybe she did. Maybe she did do a little bit of that in college, I think. But yeah, in general, she knows more about that than I do. Like, if I just, like, search Nyquist on Wikipedia, what am I going to get? Surname horse, programming language. Okay, that's not... Nyquist frequency. Nyquist-Shannon sampling theorem? I guess it's signal processing, sure. In signal processing, the Nyquist frequency, or folding frequency, is a characteristic of a sampler, which converts a continuous function or signal into a discrete sequence. Ah, I see. For a given sampling rate, samples per second, sure. The Nyquist frequency, cycles per second, is the frequency whose cycle length or period is twice the interval between samples. Ah, interesting. Right, yes. This is... Okay. I remember hearing something about this. This is why sample rates are so unbelievably high. Like the reason that we have 48,000 kilohertz. Keep in mind, humans can't hear that far above 20 kilohertz. In fact, they struggle to hear anything around or over 20 kilohertz at all. The reason why we have like 48 kilohertz, one, it's pretty good for, you know, playing around and manipulating with audio, but I think in general, it's stuff to do with Nyquist stuff. Again, this part, you can tell the parts I have studied a bunch and the things that I haven't. And this is one of those things that I haven't. But there's stuff to do with this that is the fundamental reason why we have such high sample rates. So we'll put it this way. at 48 kilohertz, we can comfortably play any sound within human listening range with ease, and there's very little chance for artifacting. But if I were to drop it down to say, and I have experiments with this a little bit, so I can at least give you some, I haven't studied the blade, but I know this practically. If I drop the sample rate down to 8 kilohertz instead, does that sound like a phone to you? Like, it's just a plain sine wave, but it still sounds odd, doesn't it? Really gets obvious when you start bringing up stuff like triangle. In fact, you can see right here, look at this. It's tapering. Isn't that interesting? Previously, at higher sample rates, we did not see that tapering. If we switch to a saw wave, even more obvious. It's not very accurate. Square wave, really inaccurate. Like, you can very much see... Let me turn that down. Funny enough, it's most stable at the lower octaves in this case. But the higher up I go, you can see just within the sample rate that we have, we can't fit that much detail in. It gets really, really difficult. So it starts sounding kind of weird. So that is why we want a high bitrate, because then we're able to get all of the sounds within human listening range with enough fidelity where the human ear wouldn't notice that it's synthesized or whatever. All right, Retzinder, have a good one. Enjoy food. I'll be eating after this. It'll be good. Will multiple notes or multiple voices bomb the frame rate? Absolutely. Yes, it would. Because we're having to do whatever calculation we're doing times the number of voices that we give the synthesizer. And that is one of the reasons why I would absolutely want... I mean, in general, just, getting things more performant is good. But yeah, definitely for polyphonic synthesizers, you want your shit to be really performant. For sure. The sine, I think, is as performant as I can get it. I think the triangle is about there as well. But the saw with all of these loops and whatever, with square... I think there's definitely ways that we can optimize that for sure. But that's something I'll need to research before I actually go in writing code and stuff. But yes, you are correct. Thankfully, currently our synthesizer does not do polyphony, but yeah, that is a thing. Can you show your 4 over pi? Here it is. I think I calculated this myself. To be clear, I actually ripped these out of the GNU math library. I mean, like, it's fine. I don't think the license covers fundamental mathematical truths, right? So I pre-computed 4 over pi here because that actually doesn't exist, but I'm going to use it pretty often here, so it makes sense to pre-compute it ahead of time. It's almost like it's been... bit crushed. No way. No way. Well, the thing is, that would be changing our... So, how do I... What's the best way for me to describe this? So that would be changing our bit depth, actually. Changing sample rates. I don't really know exactly what's the term for that would be, but bit crushing would be... say, taking our 32-bit audio and making it 8-bit audio is how I understand that. Try my damn hardest to draw a texture to an empty window in SDL2 right now. Personal recommendation, if you're not too far in, switch to SDL3. SDL3 has, it's not even just like, oh, it's newer, it's better. Like, genuinely, the API has had some pretty marked improvements. I've worked with SDL2. SDL3 is pretty nice. It introduces a lot of nice things for you that are especially helpful cross-platform. So there's going to be a lot of things you might not really get the purpose of. I didn't for a while. Such as SDL provides its own main function, like its own entry point. I don't use it because this, convention totally works on every system I plan to support. Why would I need to do this? But SDL supports a lot of different systems. It also supports consoles. like really embedded devices that have some fairly custom environments. Like we're not talking like a PS5, right? Like that's going to be pretty standard. It'll probably support the C calling convention, right? But a Nintendo DS, probably not. PSP, maybe. But you can't guarantee it. And you definitely can't guarantee, and you can probably guarantee it won't be there. You can't guarantee that you're going to have a C library with all these handy functions like sine and round. Like those might just not exist in your platform. When you're working on a more embedded device, that shit just doesn't exist. And we get very comfortable on desktop platforms because, well, you can expect there to be a standard C library everywhere you go on a PC, which is fine for me here. But if you're building for a console, not really. So what SDL's done is they've provided a whole bunch of really nice helper functions, such as their own initialization function, which you can use instead of the C one, and it will still work on any system. It'll work on more systems, which is really, really nice. And in terms of like, say me doing sine, because I do sine a bunch here, instead I would use like SDL, sine, and it would give me a double. This works exactly the same as the previous sine, at least I think so, except it is cross-platform, which is really nice. That's a good thing to have. There was something I did want to work on with this, with the synthesizer. Introducing polyphony would be one, but I also wanted to introduce ADSR, that's attack, delay, sustain, and release. So, most instruments in the real world do not just like hard play like this and then immediately drop down. And you can hear that annoying click when I release the note. And that's because we have suddenly taken our perfectly good sine wave and we've just chopped it. The second we let go of that key, it just chops it. It doesn't slowly curve down, it chops it. And that's where ADSR would come in. The idea is rather than just playing the thing immediately, we would synthesize immediately, but we would then multiply not just by amplitude, but also the value along our ADSR curve. So we'll have an attack, so you can have it fade in over, usually it would be like, if I would just want a quick sound, over like 5 milliseconds. But maybe I want it to be a really slow build up, so I might give it an attack of like half a second. And if I want it to like pluck and then hang around for a while, I'd give it a really long sustain. If I wanted it to trail off over a long period, I'd give it a long release. But the basic idea is that like even like a bass configuration that is supposed to just play a note would be a lot smoother, because we're at the very least not telling our synthesizer to go from 0 to immediately in to the wave and then immediately drop it back down. We're saying, okay, fade it in very, very quickly so that our ears won't really notice that sudden move as much, or that sudden move just won't happen, actually. We're not like snapping the thing up or down or wherever. And then when we release the notes, don't immediately stop playing. Let that play out first, and then once our ADSR value has hit a low enough point on the release curve, we'll just cut the sound at that point. We could do that. How do we feel? Do we want to do ADSR, or do we want to do some more exciting stuff like rendering? Because I've been neglecting the rendering engine in favor of audio stuff. And we can do the software renderer, we can do hardware accelerated rendering. Like, I still haven't finished the Vulkan stuff, as I said. And it would be nice to finally get that done. I think I have a to-do list here at the bottom. Yeah, by the way, that's how many... Oh, wait, you literally can't see that. That's how many lines it takes to get a Vulkan context up and running. And we're still not done. I actually haven't allocated and recorded a command buffer or drawn frames, but I have like everything else done. This is a full stage graphics pipeline, except for the command buffer and actually executing, basically. You know, I had to look at Xmake Repo and decide to go SDL2 instead of 3. You should definitely use SDL3. I think it is. I think it is kind of backwards compatible for what it's worth. They've tried to keep the API pretty stable. Not that much stuff is going to break for you if you were upgrading a project. For the saw wave, what does that POW 1K do? Does it or minus 1K? Does it ever run with like K1, 2, 3, 4? Well, yeah, it does. On the saw wave, yeah, this thing. So it starts at 1. So the very first iteration of this, it's doing minus 1 to the power of 1, which will just be minus 1, and then it does it on 2, and then 3, 4. Like, yeah, that is exactly what it does. Exactly how that actually messes with the math, less sure about that one. Like, I'm basing these off of, again, Wikipedia. Wikipedia is a pretty fucking solid source for getting mathematical stuff if you are able to read it. Like, if I get sawtooth wave. Here we are. Fourier series. Yep, this was literally the function that I copied. Except I can't do infinity on a computer if I value my life. So I cap it at some limited value. But yeah, that is saw wave, baby. That's it. My instinct tells me like half the work on the saw wave goes to that POW. Probably, to be honest. Power is not cheap, is it? Thing is, I'm pretty sure it's like fundamental to this functioning at all. Like if I just got rid of that. Oh, wait. Oh, well now it's backwards. Well, that's interesting. Wait a second. Huh. Let me just experiment with something here. Well, isn't that interesting? So our saw wave is backwards. Okay. Well. Cool. That's a really performance sine wave. Thanks. Thanks, Lewis. I think that did just, like, save me half the processing time. How much was that before? Let's quickly benchmark that real quick. Nope. Saw wave. Like 0.6 milliseconds, and I was getting 0.3 there after that change. Yeah, there we go. It's like 3.3, 0.4 milliseconds. Sweet, thank you. Appreciate it. That was very helpful. You know so much. I know this is a naive question, but how'd you even start learning about all this? I'm a simple web dev. So I do a lot of web dev stuff myself. Oh boy. How do I... Yeah, okay. Let me see if I can actually give you like a resource. Because I don't want to tell you, oh, just go out there and search for stuff. I'd say number one thing is try and be focused in what it is you want to learn. Like if you want to learn about audio synthesis, certainly just looking up, you know, computer audio synthesis. Half the time it's just like knowing how to like Google correctly, you know, how to do searches. Some people I could definitely recommend for at least what I've been doing recently. Let me actually pull up the exact channel I've been, you know, referencing the stuff I've been doing here off of. Let's go to... What is their channel name again? Not that. Oh, good grief. You know what? It's on my watch later. one of their videos that I was watching. Ah, here we go. If you want a solid fucking guy to go to just quickly learn some of this stuff, they're not doing like the exact same stuff that I'm doing, but this fella, JavidX9, also known as the Lone Coder, this guy has so many fucking guides on his channel on how to just do shit from scratch. Now, I'm a little bit biased. It's not really from scratch. It's in C++, so it is very low level, but he is using like an engine backend for a lot of the stuff, but then it is mostly just to save time and get rid of a lot of like cruft you don't necessarily need to know. You know, if you're learning how to do 2D geometry, you don't necessarily need to learn how to open a window from scratch. You don't have to learn how to like get raw pixels onto the screen. You just need to know how to like draw your own lines and shapes. So it gets a lot of the cruft out the way. And if you do want to get into that lower level stuff, that's another case where, you know, just searching around can help immensely for stuff like that. But yeah, some stuff that I have been following in particular, I wonder, can I find it? It's a pretty old series of videos, I believe. I've gone through a bunch of them. Oh yeah, I was looking at 3D graphics engine. This is actually part of the reason why Slate now has a software renderer. I was watching this and it just really, really interested me. If I go to... Oh my goodness, here we are. Code it yourself, sound synthesizer. Here we are. Tell you what, I'll drop this video in here, and if you want to just learn how to do some audio synthesis like today, get yourself a copy of, if you're on Windows, Visual Studio. If you're on Linux, I hear Sea Lion is pretty good. Get something like that. See how well you can follow along with this setup. Project setup in C is non-trivial, so don't be alarmed if you find yourself struggling to set up a project. You're coming from a web dev background. There's probably a lot of JavaScript in there. The C ecosystem is nothing like the JavaScript ecosystem. You're very much left to your bootstraps for a lot of that, for sure. But yeah, here's that video. You can start from there if you want to just learn how to do this stuff. And for what it's worth, the principles he teaches here are things that do translate to JavaScript. If you are able to establish a context in your browser where you can just pass through raw like audio samples into your buffer, you are going to be able to follow this guide and make a web app to do this stuff. And it's way easier to do front ends for that as well. So you'll get like nice visuals for it and everything. So I definitely recommend, you know, just pour through that if you want to learn that. If you want to learn how to do a software renderer, again, it was fucking this guy that got me doing that in the first place. This video right here, triangles and projection, just going into the bare bones basics. I put that with a timestamp. Apologies. I will post again without the timestamp for convenience. But yeah. Yeah, just follow this shit. Like, there are so many, like, all of these are solved problems. I'm just going back through other people's work and learning how they did it. And boy, it's been so interesting digging into all this stuff, and I could not recommend it more. It's really, really fun to dig into how this stuff works. And if you have any interest at all, like, have a fun time. Yeah, so on Linux, thank you for the recommendation. Actually, I'm trying to move away from web dev as much as I can on my free time. Yeah, I mean, I've been doing web dev a shitload in the past. I mean, it's a really easy environment to just build stuff in. I do not blame you. Like, I have a bunch of friends that have mostly only ever done web dev, some of which are now trying to, like, get into Rust and working with I'mGUI. And, like, that's extremely cool because I haven't done anything with I'mGUI yet. They're actually further ahead than me in that regard. The reason why I've moved in stuff like C is so that I can understand more fundamentally how does this stuff work, and could I ship a product in a much more lightweight package that's still like compelling, you know? That's the idea. Yeah. The problem is the abstraction. I'm too curious and I want to understand it all. Exactly. Yeah. No, I feel you. Thankfully, The only abstractions that I have in here right now, that I didn't write. We have SDL that's actually creating a window and giving me a buffer to put audio into. And I am using inputs out of SDL as well. So the basic I/O stuff that's fundamental to every system I'm deploying to, while I'm not currently using it, I do intend to use Vulkan for hardware acceleration. I'll be real. You can hand roll your own CPU, like your own software renderer. I don't recommend hand rolling a hardware renderer. You're not going to get that much benefit out of it. Like, this is the Vulkan library from, like, Kronos. The Vulkan library from Kronos. They build and maintain Vulkan. It is the language that, a language that most graphics cards speak. It's really, really good to have. You're probably not going to have much luck implementing yourself, and it wouldn't be to much benefit. I think you would still you'd still learn a lot from just implementing Vulkan. Because again, this is the library this is the language that they speak. They can speak Vulkan. So at that point, you've already learned most of what you need to learn. And CGLM is just a maths library because it's going to have a lot of optimizations in there that I'm not going to be bothered to make in my own maths library. So yeah. Yeah, it's really cool. And I want to keep this as slim as I possibly can. So if I were to ditch SDL3 entirely, I would have to create my own Windows system, my own Windows and my own audio devices, my own logical audio devices. That's okay, but the windowing part is particularly tricky because that is not an easy thing to do cross-platform. And on Linux in particular, I definitely have to introduce a new dependency just to get window decorations, like the top bar over here. This is something that the application has to provide, and it provides it by pulling in a library. I think I've been told it's called libdecor, and that is what I would use to fetch whatever the decorations are for the system, the target system, and then I actually have to render those myself. It's interesting. Yeah, anyways. I can use Ari's opinion on toolchain abstraction for beginners. Should we learn the muddy ways from the get-go, or is Xmake fine for now and I can worry about learning VC package Ninja CMake later? I'd say if you jump straight in trying to raw dog your own, like, builds, I say build systems. Okay, so you can compile an application from source in a single command, and it's not too difficult. So let me pull this up so you can actually see it. So all of the source files that I've gotten here, let me quickly query them. I can do this right now. That's how doable this is. Everything like this, and with a name that ends in .c. And I probably want the .h's as well. Cool. So what I could do here is I can go to, like, let's do Clang, Clang, the compiler that I use. Let's turn on optimizations. That's just a nice thing to do. I think I can just do, like, all C files. Let's do wildcard directory as well. I don't know if this will work, to be clear, but maybe it will. Otherwise, I have to manually specify the files, and that's not ideal. We'll tell it where we want this to go with an output flag. Let's do Slate. And see, that works. Cool. We are not generating multiple output files. I'm not sure where you got that idea from. Probably just not going to work like that. Okay, let's do, like, main.c. Yeah, okay, hold on. This'll only take me a moment. The idea here is, like, you can, if you're just looking to, like, do some stuff with, like, zero dependencies, you can build your own, you can build your own applications without relying on any fancy build tools if you want. It's just when your project gets large, as you can see here, it's going to start taking you a while to do much of anything, and this is not a nice way to work. Like, okay, oh yeah, and I haven't considered linking in the libraries that I've got here. So, like, all of my own code was actually compiling there, but then the linker failed because it has to pull in all my libraries. So like, I don't know, let's try output. Let's see. I probably want to link math, link Vulkan, link I think CGLM is header only. SDL3. Okay, that actually got really close. Holy. Multiple definitions of clamp. Did I ditch the math library dependency? I might have. No, it's still upset. Oh, it actually can't find SDL3. Okay. Well, you get the idea. You can do this raw. Don't personally recommend it. If you want a specific build system recommendation, I use Mason. And it takes a little while to get into, but I mean, this is my config file. And with a few commands, well, 2 commands, literally 2 commands, I do like Mason's setup. I have a particular thing here that like turns on a debug flag for me. And then it sets up my build directory. And then I do like, this looks complex, but all it is like, hey, Mason, compile in this build directory using the settings that are already provided. Go into that directory, run the app, and then exit out. Those last 3 parts are just things that I do for my own personal convenience, and that's it. Xmake is Lua. I think this is Lua-like as well. No, it's Lua-like. I think Premake is Lua, and that's something I have experience with as well. I personally prefer Mason. But yeah, you're not going to get a cargo run or an npm run dev or whatever in C. But Mason gets pretty close, IMO. Mason is the 1C build system I know of that approaches, that has a not horrible approach, I guess. Yeah, it's the reason I use it. I actually tolerate it. I don't really tolerate the others. Why is there a hash at the beginning of this now? Anyway. Yeah. So just to double check the question there. Just want to make sure I'm actually answering it properly. Yeah. Tell you what. For your first like hello world, do try using Clang or GCC. I personally recommend Clang if you are looking for a recommendation on compilers. I like Clang. Try just like build your first hello world with like 2 or 3 files, no dependencies, if you can. See how you fare with it. And at that point, yeah, like start introducing math functions. If you're on Linux, you do have to manually link in the math library. It's just -lm will link the math library for you. At least it should. And from there, like once you start doing projects at scale, unless you really, really want to maintain a build script, just use a build system. Like, yeah, you're not going to gain that much like extra skills from maintaining a massive build script. Especially with a whole bunch of like weird dependencies as well. Like it's going to get really, really situational. But yeah, that's my recommendation. You should probably use a build system, but there is certainly no harm in learning how to just use the compiler yourself. I've used Java C before on a college project. I specifically did not want to use IntelliJ, so I wrote it all in NeoVim with, I think, no LSP because I didn't know how to set that up at the time. Java is really weird with that. And I just used Java C. It was a nightmare. Because I had to actually like use a library as well. We're using Java effects and shit. I think I'd say thank you for the question. Yeah, that's a cool one. It's awesome to see people getting into low-level development because I mean I'm also a nerd about this stuff. I care a lot about it. Java ecosystem is a nightmare. Yeah, it's not great. It's really not great, is it? I've written enough Java in my time to have nightmares. Yeah, that's fair. Use Clong instead. My favorite compiler. We're auditing Ari's code for bugs and inefficiencies. Oh my god. Oh yeah, I was asked somewhere, I can't remember, was it you that asked, actually, Lewis, if I was going to be open sourcing this. Let me sip some water first, and then I'll... Literally had a nightmare about Gradle once. It's bad. So funny thing, I think I mentioned this before. I recently resurrected one of my. In fact, when I talk about a Java game I did ages ago, I'm talking about that project. I recently revived it with Gradle because previously, like, I originally started writing that game in Eclipse, and then I left it for years and years to go do other things. I came back to it, didn't want to use Eclipse. I think I pulled it into IntelliJ, but I also don't want to use anything from JetBrains. So eventually I got really dug in. I was like, okay, I'm using NeoVim. I'm using, unfortunately, I still have to use the Eclipse JDT LS or whatever. And I think I raw dogged a build script that called javac directly. That was fun, but Gradle does make that easier for sure, especially with the dependencies. I mean, Gradle is more or less the best that's available. Yeah. And actually, for what it's worth, there was a fork of the project, because again, this is a game that had a software renderer as well. I really wanted to introduce LWJGL so I could use OpenGL pretty easily. And I still have not been able to get that Gradle config working. It no worky. It is stupidly fucking difficult to link in LWJGL for some reason. I wouldn't mind. They basically spoon feed you the instructions. At least for LWJGL, if you go to their website, they have a thing for Gradle. But nope, wasn't working. Couldn't tell why. Didn't feel like fucking around with it. It was late that night, so I was like, yeah, fuck that. But yeah, in terms of Java build systems, I would say Gradle is like the best one that's out there. I'm not aware of anything superior. I know Maven's a thing, but like, eh. Honestly, mostly just sick of Microsoft's management of C# and their vibe coding of the .NET Core. I didn't know they were vibe coding .NET Core. I shouldn't be remotely surprised though. Thought might as well go low level. Telling a beginner to programming to use Eclipse is awful. To be fair, at the time when I was writing Java, that was still kind of the best IDE out there. I didn't know any better. Yeah, it wasn't great. Heard really good things about Mill. Never heard of Mill. My friend introduced me to dev with Eclipse for Bucket plugins. I didn't even understand that classes are just files because Eclipse's UI abstracted that away from you. Oh my god, yeah, that! That's still such a big thing in the Java ecosystem too. I think it like kind of happens with C++ if you're using Visual Studio, I guess, but also fuck Visual Studio, right? To be clear, I actually don't know of a better debugger than Visual Studio's. That is something I'm gonna want to poke at because as much as I like LLDB, a text-based debugger really doesn't have much swag about it. And it can be a little clunky to use. Like a visual debugger is quite nice. I want to see if there's like some very Linux-centric open source C++ IDE that I can lean into, or a C++ IDE that actually has like visual debugger stuff in it, because that would be pretty nice, not gonna lie. Girl who says she never did FFI. Referring to me or Nell? They left a Claude skills file in the repo on accident. On accident? Wait, did they pull it later? That's so funny. Oh, they don't even want to admit it. That's so funny. Even if it continues the JVM ecosystem sin of not knowing what the hell a lock file is. Oh man. Oh yeah, referring to me. What did I say that's indicated I've done FFI? I'm curious. All right. I forgot already. Let's go. Right. So, in case you haven't noticed, we're at the 2-hour mark, but we have barely written anything, and I would like to write something, right? So here's the idea. I am going to... let's see how well this works, actually. If I go... Yeah, this render function is just kind of here. Let's do if def slate. Oh, I guess like if and def, right? Yeah. Yeah. Essentially what I'm going to do is I'm going to just turn off the software renderer. I'm going to fuse it off when the Vulkan build flag is on. And let's see, actually, can I just do that real quick? Can I reconfigure with a new flag, maybe? What would that be? Slate's Vulkan. It's like, what was that I did before? Hold on, let me double check this. Mason setup, debug true. Yeah, so I guess like, oh wait, hold on a second. It's a Mason flag, isn't it? Yeah, so I want to add. Yeah. Get option Vulkan, and we'll do Slate's Vulkan. I just realized something. That's supposed to be Slate debug, isn't it? I changed the convention for that. Yeah, no wonder my fucking debug log functions weren't working properly. Well, that's fun. Okay, cool. So I should be able to do this, maybe? Oh, wait. Okay, helpful. Thought there was like an option file or something. Perhaps not. Perhaps I have to specify that. Yeah, I think debug is like a default. Oh man, is it like mason.options.properties or something? Hold on. Let me peep this. Mason options, build options. Mason.options. Yes, I was correct. And I want an option, Vulkan, which is type, should just be Boolean, I presume. Yes, with the default value. We'll say true, actually. For the fuck of it. So yeah, we're probably not going to use the CPU renderer very often. In fact, should this really be... We shouldn't have a build option for Vulkan. No, hold on. Let me actually think a little bit more long-term than this. Realistically, what I'm going to want is for that to be like runtime definable. So let's instead go to the Slate app here and we'll just add... We'll introduce an enum in here probably. Type def enum slate renderer. Yeah, just slate renderer. That might have a name collision with something I want in the future, but we'll burn that bridge when we come to it. So we're gonna do slate render Vulkan. And slate render software. There we go. And we will then say in here slate hello. Sure. Yeah. Should this be like slate render mode? Oh, Lewis, you're heading home. Let me read your message just real quick. I know you ain't touching audio anymore, but I'll say one more thing to chew on. You seem to be calculating sine of theta, then 2 theta, then 3 theta, given the first two. How to get the third one without calling sine again? That is something to chew on. I don't know. There probably is a faster way to do that. Yeah. Unfortunately, I'm not that fresh on my trig where I could answer that. But yeah, food for thought. Thank you. And have a good night. RGPT, please generate me code for replying your mom to my ex automatically. Wait, for real? So one of those days? Oh dear. Okay, yeah, we'll have renderer there. And what I'll probably do is in slate.c. I probably want like some flags, right? Probably. Slate init flags. That's what we're gonna do. We're gonna have some flags here. Yeah. Okay, that seems fine. Software renderer, Vulkan. Yeah, okay, so this is just not stuff that's going to be super visible, so I will just like make those enums a bit more explicit. Cool. And then I keep pulling up audio because that's what I've got in Harpoon, but I really want that to be Slate stuff real quick. And we will do, well, probably int flags, I guess. Oh, shoot. Yeah, wait, no. Yeah, I made these enums. They're supposed to be flags. Init software render. I gotta think about that, don't I? We'll start simple. I don't know, something like that, I guess. I don't expect to have that many initialization flags, so... In fact, oh, right, because they're supposed to and together. Kind of answering my own question here. Guys, you isn't looking at chat. Quickly, drop license key structures. What the fuck? Cool. Okay, that's 32-bit. Let's do 64. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait. 1, 2, 3, 4. That should be 64 bits. 39, 70. Huh? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That is 64 bits. Awesome. I've just heard that I have food downstairs, so tell you what, I will be back in just a moment, and we'll get right back to the business. One sec, guys. Sweet and sour pork and noodles, baby. I am living the high life right now. Right. I ran back up the stairs and I'm admittedly not that fit, so give me a second. And I'm also going to eat a little bit of this food before we get back to the code. Actually, I'll go here for now so you can at least see what I've been doing. Also, May, yes, hello, how are you? This shit is like fresh hot. I don't know if I can eat this right now. I might need to let it cool. Let's find out. Let's see if I burn my mouth real quick. Well, as long as I'm careful, it's about just right. Let's go. Doing swell. How's the renderer? So I haven't touched renderer just yet. In fact, I'm actually expanding Slate now to support both the software and Vulkan renderer at the same time. Oh, so this is way too loud. The idea is that it's going to be like runtime assignable, basically. What I have done though, and hold on, I'll tell you what, I'll fix up this code real quick and I'll show you. The synthesizer is working, May, like 100%. There's some caveats to it, but it's in a really good spot. I'm excited. I think you will be too. So yeah, tell you what, we'll still need some way to tell Slate what renderer you want to use, but I think for now this is fine. You know what, actually? Hold on. Let's do some tidy up that I really should have done a while ago. Window creation. Why in the good goddess name is this in our main application function? This should just not be there. That's not good. So I'm gonna lop this out of here. We're gonna go into slate.c. We're gonna go into initialization. I'm gonna do if flags slate init Vulkan. Then we do this. And assuming it fails, we fail. You know the deal. Which key is it again? This one. Cool. We can't return slate app failure now, but we can return null. And that is okay. That'll be fine. So I think what we do currently is if create app returns null, then we just exit the program anyways. But we provide good logging for this anyways. It should be legal for me to burn girls' mouths. Unbelievable. Window size. Yeah, we never did specify that, did we? Int width, int height. We'll be kind of lazy with it. Yeah, cool. So we're going to create that. Awesome. Slate Vulkan init, passing in... That's already a pointer, so that's okay. Slate Vulkan init. Really, bro? LSP just does not feel like working today. Actually, wait. No, we have the Vulkan thing in here. I don't know why that's complaining. Ah, right, and I don't have my Mac Vim config in here. Call to undeclared function. Your mom? Oh shit, no, it actually does not exist. What? What the fuck? Vulkan.h? Oh, it's fucking VK in it. Wait. Oh, you know what? It never bugged me about this because that code path was fused off by the thing. Okay. I guess yeah. So here's the thing. I mentioned briefly today that I considered rewriting Slate in Zig. And that's because I've been looking at the Zig overview, and it has some ergonomics that I really would like right now. So say a proper result type that gives me either the value or the error, or an option that gives me either the value or nothing, and allows me to handle that very gracefully in either case. And what I'd really like right now is deferring on an error specifically a deallocation or a memory free of this window, or at least destroying it. That's what I would like. Julia, you don't like Zig. Please pray tell. I shrimply must know. Okay, that's good enough for now, though. I would destroy the window, tidy up. I'll say on signal. Oh, dear. Oh, no. She's going to say some shit that's going to make me go, oh, good heavens, and I'm going to switch to Rust or something. Either way, I love C for the low level, but it does have some pretty nasty ergonomics sometimes, and it does make me want to write in like any other compiled language. You know what? I just realized a software renderer flag is kind of not necessary, isn't it? It's kind of a nothing burger because like we're either using Vulkan or we're not, and it's an optional flag. So that can just be the else case. Whoops. Cool. We can't return Slate app failure. We will turn null. And that's the parameters for our window. Renderer. We do this, we do that. We're definitely going to need a proper abstraction. So like we have software renderer, but this really needs to be like a generic renderer that has different backends to it. Yeah. Thankfully, I'm building the software renderer in such a way where it is very similar to what I would expect out of a GPU API library. So that's something at least. Okay, any other errors in here? Conflicting types. Oh, right, of course. Let's go down to that init function down here, or that creates function, and slap that in. Cool. Probably want to create that audio synthesizer here, I would say. That'd be a good idea. Yeah, we return, well, we print out an error by the time we get there. You know, I just realized if I could be the change I want to see in the world. I could make a results type in C. It wouldn't be nearly as ergonomic, but I could. Oh wait, no, can I? Ugh. It'd be like a malloc struct with either an error void pointer, because I don't know, maybe it's a string, maybe it's something else. Maybe it's an error code. And then a void pointer to the actual intended type. Maybe I would want to look into like how other people have done that before I go just throwing that in for shits and giggles. Because like it's all well and good if I have it, but if the developer experience is going to be shit anyways, there's kind of no point. Because I'm just side grading to another piece of nonsense. I'm going to eat some food real quick again. Need some good ass noodles. Holy. It probably helps I was already like actually kind of hungry as hell. Damn, that is pretty good. Ah, I see. I understand now. Main.c. Okay, you need a name. I guess we just take these parameters that we were doing over here and we shove them over there instead. Let's drop this down to a new line. We'll do... Well... Tell you what, we'll do some cool tricks here. if this one. If width equals 0, then width equals, oh my goodness, keyboard. Can you tell I'm still a little bit new to writing code with this thing? Cool, we have that. We're gonna do the same with height. Specifically those keys right around the center that are getting me right now. Cool. So now we get to do some wacky stuff, like saying we want a 0 by 0 window, but it auto fills the things that we actually want. I don't know why I just don't have IntelliSense autocomplete here, but whatever, I guess. Cool, we have that. Window size. Oh, that upset you greatly. Ah, that would be why. Well, you know what? I haven't had a proper place to store this shit in a while. Renderer should probably have a width. Whatever. Let's do window width. It's fine. It'll be fine. I'll chuck them up here. And then in Slate C, let's do app width equal to width. Window width. And height. Like that. Perfect. So now I can instead do app window width. I realize I've been using the term app everywhere as like a generic app context thing, but this should really just be like Slate. Or like engine. I don't know. We'll call it Slate, because then I'm like really sure of what it is. It is the engine. The general idea that I have here, by the way, is that I am trying to... I'm going to just replace every case of app here, but I just want to be careful. Even a little bit careful. The idea here is that I can separate this from... So, like, what I'm dealing with in main.c, this is, like, the end application that's built with Slate. And I want to separate that from the engine code. Because that makes this, you know, actually portable. It means I can actually use this on other projects in the future without having to do, like, a weird hacky, okay, let's strip all the engine code out and bolt on something new. Also, I think it's better engine design in general, I feel, poisonally. So that's going to be the end of some condition. That's on a define. That's if not Slate Vulkan. So if the renderer is Slate's renderer software. I realize I never actually set that parameter. Or, yeah, I never set that field, so I'm gonna have to make sure that I actually do that. And we'll do else. Hello? Nope. This was one of these keys. Nope. There we go. Knew I'd get there eventually. For those who don't know, I am rolling an ortholinear ergo split keyboard, and that's it's a really nice keyboard now, but it's very different. I'll put it that way. I knew I was hearing stray music. It's so good. It's so peem. It's amazing. I love this. It's so good. Cool. Okay, so that software render doing its thing with our example lines and stuff. I'm probably going to get rid of that test square. It's kind of not important in that one as well. Just save us a bit of stuff. Cool. That's all well and good. This is... yeah, Slate should have its own render function that we can just slap our own stuff onto, but most of the stuff is okay. I guess, like, maybe I'd keep some of, like, this stuff here. Maybe verts and tries. This is very much like a game-specific bit, so I don't know. We'll figure that one out. Did a bit of Stray speedrunning last year. Oh, fucking rad. That's awesome. That was such a fun game when I played it. I couldn't imagine speedrunning it, though. Like, I love the world too much. I'd have to, like, really take my time. I get too distracted. It's only the second game I've ever speedrun. Oh, sweet. Nice. Okay, let's see here. Okay, so we initialize. And... oh, SDL set at metadata. Okay, yeah, you absolutely should be over here. Cool. And yeah, I realize we don't even have a null check here. So let's do if slate equal to null. Then we will, I guess, just immediately return out, right? Yeah, it should be fine. Let's actually make sure I do this, because I fucking forgot to do this. Alright, so we got that same app problem as before. Let's just call it Slate. Let's replace all of these nice and carefully. Cool. And Slate renderer equals Slate renderer Vulkan. And if not, we'll make it Slate renderer software. Is there a case where the software renderer fails? I don't think I already checked that. No, there's no case in which this fails. It's just allocating stuff. I would be amazed if these mallocs failed. Genuinely amazed. That would be a wild one for sure. Hard to pick a favorite from the soundtrack, but man, Bushido Calculus is a bop. Man, I've only been listening to this slice of the introdiegetic soundtrack for so long. I actually don't know which song that is, but I could find it. Let's see. Oh my god, Luna, thank you for the tier 1. Thank you so much. I appreciate the fuck out of that. That's so cool. Thank you. Oh yeah, this one. Yeah, that song fucked. May, I'm thinking a different one. Though I see what you mean. We know someone else with a similar name. Thank you for advice in stream. Hey, thank you for the support. Appreciate the fuck out of it. It's one of the reasons why I commit myself to doing the streams, because, you know, get to do cool shit, hang out with cool people. Right. Okay. Slowly but surely tidying up this API. The engine should be advertising itself when we're ready to go. Cool, so we set our own stuff, we start the game, put it here. Yeah, we dump our stuff into here, that's all fine and well. And then we start our game loop. Awesome. Except it's not, because this is still... yeah, there's still just a lot going on in here. I mean, okay, a lot of this is, to be fair, fairly game-specific. I suppose, yeah, we'll have our input system and whatever, so we'll be getting rid of this eventually. This is kind of, we're bolting shit on right now, as it stands. I'd probably do, like, maybe you pass in an update callback to Slate for processing stuff. That's what I'm thinking. Go to eat now, but I wanted to squeeze that in beforehand. Hope you have an awesome rest of the day. Hey, hope you have a lovely sleep. Thank you so much for stopping by. It's been a pleasure. Hope to see you around again. Only plays the in-game radio around when you enter Midtown. Oh, I see. Yeah. Such a good game. Amazing atmosphere. I'm gonna quickly chomp some more of this food real quick. Such good noodles. My good heavens. Right. Cool. Okay. Yeah. Right, that's where I want it. Yeah, audio thread. That's definitely something the engine should handle itself. Yeah, we're not going to get the whole thing out of the way. There's still going to be a lot of stuff in this main file, but we're getting pretty close, I think. And that's good. Wonder should I have, like, in source, there's a separate, like, engine and clients directory? I'd say, you know what, it's probably too soon. It's probably too soon to be doing that. I'd say when I have main.c trimmed down, like, a huge amount, that's when I start splitting this out, and I actually start separating the, like, application, like, the game layer test code from the engine. That's what I'm thinking. Okay. Oh boy, I have to pull up Vulkan docs now, don't I? Oh shoot, I'm only gonna have so much time. I'm only gonna try to keep around for another like 15 minutes or so. Well, let's see how quickly we can do this. Okay. Good grief, where was I in this book? Tutorial structure. Ah. Is this the place to be now? This change? Tutorials. Chronos Vulkan tutorial? Okay. Okay, no, this is looking closer to what I was actually doing. Yeah. Okay. Drawing a triangle. Yes. Graphics pipeline basics. Oh boy. Yeah, okay. There was a lot of code written here. Unfortunately, I really don't feel like going through all of it right now, but to do dynamic rendering. Remind me. What's the importance here? In previous versions of Vulkan, before we could finish creating the pipeline, we needed to tell Vulkan about the frame buffer attachments that would be used while rendering through a render pass object. However, with the introduction of dynamic rendering in Vulkan 1.3, we can now specify this information directly when creating the graphics pipeline and when recording command buffers. Interesting. Dynamic rendering simplifies the rendering process by eliminating the need for render pass and frame buffer objects. Instead, we can specify the color, depth, and stencil attachments directly when we begin rendering. Tell you what. There you go. There you go, Ari, in the future. Saved you some time. You can have a look at that at your leisure. Okay, I guess we just go straight into command buffer. Because, oh, yeah, wait, it's the whole thing here on dynamic rendering. Well, I guess I'm going back up to here to slap that link in there, because that's probably where I actually want to be for that. Okay, allocate and record frame buffer. That's going to be this one. I'm gonna eat more food. I am still very hungry, and I'm going very slowly because I am live and time crunched now, because I'm actually trying to get like some meaningful stuff done before the stream is over. Hey, look, there's always Saturday, right? Assuming we are doing this Saturday, it's looking like we will be, and that's great because I will have an abundance of time on my hands to work on this on Saturday. No problem. Okay, go a little bit more in me. Good. Okay. Commands in Vulkan, like drawing operations and memory transfers, are not executed directly using function calls. You have to record all the operations you want to perform in command buffer objects. Interesting. That makes some sense, sure. The advantage of this is that when we are ready to tell Vulkan what we want to do, all the commands are submitted together. Vulkan can more efficiently process the commands since all of them are available together. Yeah, economies of scale, basically, but for performance. In addition, this allows command recording to happen in multiple threads if so desired. Oh, interesting. We have to create a command pool before we can create command buffers. Command pools manage the memory that is used to store the buffers, and the command buffers are allocated from them. Okay. Yeah, I forgot this is a C++ guide, so this is going to be interesting. How much space have I left between these? As like individual steps, I leave like 3 lines between. That's my convention here. I'll stick to it. Slate error, slate, VK. I guess create command pool is probably where I want to start. Oh, I realize why it's called app everywhere. Because the actual struct is slate app. Okay. Should probably rename that. I could just call it Slate, right? Let's just call it Slate. Yeah, whatever, dude. Do same here. Unsurprising, a lot of broken shit here. Good, not that many other locations where that exists. That's nice. That was a nice and easy quick fix. Happy with that. Cool. VK destroy, VK init. Yeah, VK create command pool. I guess we just copy this, right? Create command pool. Because I imagine we would want to create our commands in the game itself, is what I'd be thinking. Why are these underscored? I guess that's my convention for private methods? Private functions? Sure. No, that is kind of weird. I don't know how I feel about that one. We're gonna do this. Yeah, I prefer that a bit more. Do we even do that with helper functions? Oh, well, we don't know now because I've gotten rid of that. That's fine. That's okay. Okay. Command pool. What the hell are we doing? And how do I translate this stuff again? I need to create a command pool. Tell you what, I'm going to quickly restart Vim because I'm definitely going to want IntelliSense for this one. Did it just give me an LSP error? Oh no, here we are. Right, I'm using SDL functions for this, aren't I? Or not? Hold on. Right. Yeah, that's how that works. What's the object again? VK, yeah. VK command pool. Ah, it's all coming back to me. It's all coming back to me, baby. Oh, it's been too long. I'm on a completely different keyboard now. This is going to be so much fun. What's my standard for doing this? Yeah, I just create the object, 0 initialized, and then I add all the things that I want. Okay, cool. Command pool dots or not? Wait, are you just a handle? Oh shit, you're a handle. Okay, so you're just null then. Do I use null PTR elsewhere? No, just null. What do I do with handles, generally speaking? Come on, surely I create some kind of logical reference somewhere here. No, that's swap chain capabilities. Surely like device creation is like a logical thing. Physical devices. No, it's an array of pointers. What the hell, dude? Where is it? Could be some example of this. I just want to remember what I did so I have a convention for it. Oh, the debug lines for this. Right. Oh my god, wait. I gotta... Can I maybe... Well, actually, yeah, when I rebuild, it's just gonna show me the debug lines. That's fine, actually. Yay, we get to see all the cool... Oh, wait, no, we don't. No, because it's commented out. Ah, give me that shit back. That's so cool. It was like one of my favorite things. If def slate debug. What the fuck? Can I just do slate debug? Wait. If def slate debug. Oh, wait. Is that because... Hold on. Log H. Ah. Tell you what, you know what? Nah, there's no point. I know what I do here. Site log debug. There we go. And then we just ignore that if the debug thing isn't set, is the idea. Cool. And over here, replace these slate logs with slate. Oh my god. Whoa. Slate log debug. There we go. That's what I wanted. Do it again on these. State log debug again. Go through all of those. Enable validation layers. That's... Okay, that's on in this config anyways, so that's fine. Yeah. Cool. Awesome. Okay. Cool. That should be fine. And we reference that. Oh, no, hold on. We have another. Let me fix that. Whoops. There you go. Cool. I think that's all the debug lines reintroduced now. So we get to see all of the funny logs. There is going to be like an assload of shit blasted into the console for this, but it'll be cool to look at, you know? It'll be worth it. And it's like debug flag anyway, so like, yeah, of course. Okay. Command pool. So we start with null. Oh, yeah, we literally do start with null. Of course. I'm gonna eat some more food real quick before I proceed. Let's get into this bowl, baby. Trying to get at more of this before it gets cold. Been here long enough. I mean, my room is warm enough, but still, it's gonna get room temperature eventually. And I do not want that. Thanks for reminding me to make food, actually. Yeah, please do eat. No time to the present. Okay. We got like a minute. Let's see if we can get a command buffer. Cool. Create command pool. Cool. Pool create info. Okay. And that is going to be... Well, I guess we'll start with 0 initialization. And then create info.flags. Haha, I knew it. And a Q family index. Uh-huh. So we'll need to dick around with both of these. As for the flags, 2 possible flags or command pools. Transient, hint the command buffers are recorded with new commands very often. May change memory allocation behavior. That's probably fine. I'm not going to worry about that right now. And reset command buffer. Allow command buffers to be recorded individually. Without this flag, they all have to be reset together. Huh. Command buffers to be recorded individually. Huh. I'll leave that for now, but I'll keep that in mind, I guess. Try to, anyway. I think there's something wrong with me. With absolutely no experience in text adventure games whatsoever, I decided I want to make the most world simulation heavy text adventure ever. Hey, that's fucking cool. Honestly. Doing cool shit with text adventures in the Big 26 is almost as cool as me raw dogging a handmade game engine in the Big 26, so... Yeah, that sounds sick. Might as well like push that world building immersion. I mean, with a text-based adventure, you're putting all your chips into the story, into the writing and whatnot. That is pretty important. Okay. We will be recording command buffer every frame. Oh shit. So we do want to do that. I was thinking, yeah, that sounds like it might be important. Okay. Command pool create flag bits, reset command buffer. Okay. That's not filling me with confidence. Oh, the structure type? Ah! No, it is under VK command pool. God damn it. Oh, wait, that's not correct. What the fuck? Why did you put me here? Oh, right, because that's where I was. Of course. Flag switches VK command pool. Oh, I could have just checked that as well, I guess. Yeah. That's fine. We're back. Q family index. Okay. So I have this somewhere, I presume. Graphics queue? Is that right? That doesn't feel right. Yeah. That's a VKQ. Maybe I didn't. Q family index. I graphics Q family. Ah. Okay. Let's rename this. Yeah. Okay. Yeah. So we do need to store that. That's fine. That's okay. That's going to be under... What the fuck am I doing? Slate H. Vulkan context. Give me... Would this be an int? I actually don't know. That's a UN32T, yeah. UN32T. Graphics. Family. Index. Oh, wait, graphics Q family index. There we go. And then just, I guess, around the last place where we actually utilize it, you know, we get our Q device. App vk.graphics Q family index equals graphics Q family index. Just like that, baby. Easy as. Cool. All right. Back over here, we now actually have access to this. Bingo. Trying to make an environment responsive movement system, though I'm not really satisfied with it. At the moment, I've achieved that through manually written tables for the traversal policy of a small selection of entities that can traverse. I prefer being able to construct a traversal policy for some kind of agility skill, I think. Interesting. Yeah, that does sound in-depth. Power to you. Command buffers are executed by submitting them on one of the device queues, like the graphics and presentation queues we retrieved. Each command pool can only allocate command buffers that are submitted on a single type of queue. Interesting. We're going to record commands for drawing, which is why we chose the graphics queue family. Okay, well, yep, that makes sense. So we have our command pool with device and pool info. Ah. So VK command creates command pool. Nope. That ain't it. Command pool. What's the... Ah. It's a lowercase VK. VK create command pool. Bingo. App. VK device. Create info. That's a pointer to this. P allocator. Null. I remember we don't have a special allocator. We'll just use the defaults. And where we want the command pool. Bingo. We'll need to check the result of that. So let's just make sure we handle that. I'm just gonna use my placeholder thing for this. Cool. Fail to grate Vulkan command pool. Easy as that. Cool. So we should now have a command pool. We can now start allocating command buffers. You create a command buffer object as a class member. Command buffers will be automatically freed when their command pool is destroyed, so we don't need explicit cleanup. Cool. I'm definitely going to specify that in here. VK command buffer. That I believe is a handle. That is a handle, right? It's a handle. Nice. Makes that easy to work with. Okay. Yeah. Okay. Cool. Create command pool and create command buffer are separate in this case. Okay, that's fine and dandy. I imagine this is going to be very similar. Oh shoot, yeah, we need to like actually store the value of that command pool somewhere. So make a command pool. Just keep those together. That might be useful. VK command pool equals, you're not going to believe this, command pool. And we'll slap that on there. VK command buffer. Let me guess, it's going to be command buffer. Ooh, allocate info. Yo, it is allocate info. Okay. And we will see exactly what this needs. Alloc info dot. Okay, command pool. That seems pretty obvious. VK command pool. That's our handle. And then this is command buffer count. What do you use? 1. Sure. And command buffer level. That is primary. I've went through every key on my keyboard except for the one I wanted. Okay. Where? VK command buffer level primary. There it is. Slowly but surely remembering how the C bindings for this work. Okay, command pool is that. Level is primary. Count is 1. Okay. What the hell is this move? Okay, that's definitely just a C++ weird thing. Cool. Command buffers. Is that just a function? VK command buffers? Maybe it's under creates command buffer or not. Wait, yeah, what? Command buffers with device and allocation info. Yeah, that definitely should be a thing. Oh, wait, would it be VK allocates command buffers? Ah, yeah, that's it. Cool. Allocate info is going to be null. Command buffers is going to be, or sorry, the allocation info is going to be that. Wait, was that not right? That was not right. Ah. Wait, that's interesting. How do I configure that, though? That seems like something I'd want to configure. Allocate command buffers. That's the only related function I can find. That's interesting. That is very fascinating. Let's see what we got here. Surely there's something. Begin command buffer? No. Reset? No. Not end either. You know, maybe it'll be in like the related. See also. VK command buffer. Allocate command buffers. Allocate command buffers from an existing command pool. Okay. That's not telling me a whole lot. Oh, wait. Is that supposed to be allocation info? Oh, for fuck's sake, it is. Okay, well that answers my question. Sorry, I was thinking it was like the allocator from the function above where I'm supposed to provide null because I don't have any custom allocators. That was not the case. Okay, failed to create command buffer if it fails. And command buffer with command buffer. And that should be hunky-dory. Because we're create a pool, we create a buffer. Awesome. Back to this. We'll make use of the secondary command buffer functionality here, but you can imagine it's helpful to reuse common operations from primary command buffers. Sure. Since we're only allocating one command buffer, the command buffer count parameter is just one. The command buffer's constructor generates a standard vector of command buffers, but we just want a single one here, so we'll move it out of that vector into a single variable. I see. Right. Yeah. Yeah, I guess we're only allocating the one. Like that is actually suitable. That should be okay. Right. I think that'll be okay. Second guessing myself now. Tell you what, we'll find out. We'll find out if it's a problem. It is a handle, so like there's not that many other ways we could actually pass it through. I think it's fine. As long as we're setting the value, I think that'll, like it's allocated, it's there, we're fine. Noodles, man. Love me some noodles. Right, back to it. Yeah, that should be fine. We'll now start working on the record command buffer function that writes the commands we want to execute into a command buffer. I'm feeling like this is something that we want exposed, but we'll find out. I'm thinking this is more than just setup. The command buffer used will be passed in as parameter, as well as the index of the current swap chain image we want to write to. We always begin recording a command buffer by calling command buffer begin with a small command buffer begin info structure as argument that specifies some details about the usage of this specific command buffer. Okay. You do this anywhere in particular? Is this in init Vulkan or... You don't say. You really don't, so I'm going to take some creative liberties here and assume. I probably want to replace the Slate's VK lines with Slate's V lowercase k. I'm just feeling that today, you know? I'm feeling that sort of way. Yeah, that's all handled up there. Slate.c is probably going to complain about this, though. As I thought, and now it's fixed. Good heavens. All right. We create a command buffer, pass in our app, and... Right, we want the image index. Okay, this is almost certainly going to be public. I'd be very surprised if it wasn't. Say they're okay by default. It's pretty much how I'm adding to the traversal policy at the moment. Add to policy mode bogged prep through actions trudge pod. Oh, interesting. Public in my C? I more mean am I exposing this function in a header file is what I'm getting at. And I'm getting the idea that I might want to, because recording command buffers does not seem like something I would be doing just on the odd occasion. So yeah, I'm just going to take every instance. I'm going to be slightly lazy here, and I am going to allow myself to just call them all Slate. Because I prefer those ergonomics. We do have an error. I fucking knew it. I fucking knew it. Knew there was going to be a problem. And of course it was on this file where there's actually a problem. Unbelievable. Cool. Yeah. So that's taken care of. Alright, recording our command buffer. We want to begin to start with, I guess, with empty stuff. Yeah, we'll define this anyway. Command buffer begin info, and we're just gonna 0 initialize that. Should be good. Oh dear. Okay. Is it gonna be like VK begin command? Yeah. Okay. There it is. Command buffer Slate's VK command buffer with our begin info. Specifically a pointer to that. Can this fail? It's VK results. It can fail. So we will chuck that over there. Replace this with that. Failed to start Vulkan command buffer. Let's say failed to begin. I think that's fine enough. Cool, so we begin it. Awesome. Oh yeah, there are flags. We might want to look at the flags. Inheritance info and flags. What are the flags? One time submit, the command buffer will be re-recorded right after executing it once. That's interesting. Render pass continue. This is a secondary command buffer that will be entirely within a single render pass. Huh. Simultaneous use. The command buffer can be resubmitted while it is also already pending execution. Yeah, none of those seem applicable to me at this time, so I'm going to ignore it. The P inheritance info member is only relevant for secondary command buffers. Okay, that I don't care. That's fine. If the command buffer is already recorded once, then a call to command buffer begin will implicitly reset it. It's not possible to append commands to a buffer at a later time. That makes sense. Well, that's the whole point, right? You're storing those commands and you're putting them somewhere optimized. It would be weird if you could just tack onto them at random. Each entity in the world has a list of possible interaction prepositions, an optional mode switch, and also a height depth value to know how much taller or deeper it is in comparison to the traverser size. God damn. Fascinating. That's cool. That's very in-depth. Very, very nice. Are you doing like, is it terminal based, or are you doing like a little web interface that's just like a text box with your various actions bias or something like that? Because I've seen some people do that, and I think that's a really, really neat take, like evolving it. Terminal based at the moment. Yeah, that's fair, that's fair. It'd be cool to port it to web, because I mean, you don't have to download textures or anything, right? It's just prototyping? Yeah, that's also very, very fair. For what it's worth, that would be a really cool deployment method for a game like that. I know it's worked before. I played a little text-based adventure game that it was web-based, and it even had like sound design to it. Like they'd play atmospheric sounds and whatever, depending on the situation. It was really cool. Before we can start rendering to an image, we need to transition its layout to one that is suitable for rendering. In Vulkan, images can be in different layouts that are optimized for different operations. For example, an image can be in a layout that is optimal for presenting to the screen, or in a layout that is optimal for being used as a color attachment. Use a pipeline barrier to transition the image layout from undefined to color attachment optimal. Okay. Oh, wow. That's a function, huh? Okay. Well, tell you what, I am going to kind of lazily copy this in, I think. Wait, so we begin the command buffer, and then the transition image layout. Wait, huh. Okay, well, I guess we have our command buffer thing. Maybe this is just a separate function. I think this is. It's an entirely separate process. Yes. Transition image layout. That can't error, can it? We'll find out. Slate VK transition image layout. I think these could just be VK image layout. Yeah, it likes this. That is okay. And I personally like having these laid out like this, so I'm gonna leave them as such. And can I do that? Oh no, it hates that. Oh, did I manage to fix the audio issue? Tell you what, this is in an awkward state. Give me just a second. Fuck yeah, I was gonna show this off, and then I was I just distracted by Vulkan. Let's see if this builds. It might not, because I'm in the middle of doing some stuff. Okay, yeah. Creating command pool. Yeah, tell you what, we're just going to ignore this for now. For the sake of getting stuff on screen. Okay. Oh, right. Seg faults. Of course it's a seg fault. Why wouldn't it be a seg fault? Okay, I'm a little concerned by that, actually. Because I don't know exactly where that's occurring. That should be fine. Slate synth should certainly exist. Tell you what, actually, let's debug that. Ah, that's not it. Build, debug, Slate. And let's run. Hope for the best. Yeah, that's not good. Oh, validation layer problems. Oh, dear. Oh, p create info code size must be greater than 0. What? Why? Create shader module. And we use that in 2 places, I guess. Oh my god, wait. Is that why... SDL load file? That loads from the local directory. You compiling at exactly the same time as me just pulled me right out of thoughts. That's funny. Code size must be greater than 0. Oh, wait, yeah, we never check if that failed to load. Can that fail? Returns data are null on failure. Yeah, okay. Be really curious to see you try cdev and cline and report back your feelings on it. It wouldn't be any of them. It wouldn't feel like home. Though I have suggested to people who are not, who are like just getting started with C that they should probably use an IDE kind of like cline. Okay, so if vertex code equal to null, I have to wrap up soon, so let's hope I can actually get this done. What would this be? Slate, error, I guess null pointer in this case. This isn't like a great case here, but whatever. Fail to load shader file. Yeah, fail to load vertex shader. We'll be specific here. And that would be SDL get error. Cool. And we will do the exact same for the fragment shader. Fail to load fragment shader. And yeah, we'll exit. Yep. And just trim all of that off. Oh, wait. No such file or directory? Yeah. Okay. Well, it's good that I actually have that error in, because I did just pick it up what was going wrong there, but yeah. Slate run. Should perform better now. Gotcha. Okay, render VBO. Ooh. Okay. Oh, because we never set up the renderer. Ah. Okay, yeah, though that's such an easy fix. That's fine. If slate renderer equals slate renderer software, then we do that. Otherwise, oh, fucking hell. Otherwise, we just don't. We don't bother. And we'll exit. Mason compile. You know, I'm feeling lucky. Let's see if it works. Uh-oh. We have a Wayland window that's really struggling to come together. That's a tad concerning. I might know why that's happening. Maybe. Let's find out. If renderer software... Oh, what the fuck? What are you doing here? Oh, I know what you're doing here. That's for the silly we text, right? We're just gonna get rid of that. We don't need that. Set render scale. Yeah, no, that's fine. Render present. I mean, render present happens regardless of what we do. We only do this texture presentation stuff if it's software renderer, or we just clear the screen. One of the two. They have Vim mode though. I guess you gotta understand there's a lot more ergonomics to this for me, you know? The only reason I could see myself pulling up an IDE right now is if I needed like a really in-depth debugger that showed me a lot more than what LLDB currently shows. But if I'm just diagnosing like null pointer exceptions, or not null pointer exception, but null pointer problems, null pointer dereferences, then like I can use LLDB for that. That's perfectly fine. Okay. So we run that check. Does the bug still happen? Tell you what, let's LLDB that. Okay. And you just don't feel like showing up, I guess, for reasons? Can I step out? I swear there's a way to do that. Trying to remember. I guess we could single step. Oh, cool. I could just keep going. So I'm in some printf stuff. I'm writing something to the buffer. C code, ma'am? Anywhere? Hold on. I come back out of my own head to exclaim my hate for nulls. Kill them. I fucking agree. C# would like to have a word? Does C# not have null or something? Step out of current frame. Thread step out. Okay. Again. It's a VSN printf. SDL thing. Oh, what SDL problem have we got? Set render draw color. That's what failed? Oh, it's the first SDL call that we have. Okay, so there's something going wrong with how we're setting up our SDL renderer then, is what I'm getting out of that. Flag, Slate, init, Vulkan. Oh, wait, did we pass that? We did pass that? Okay. So we create our window. We create our Vulkan. Slate renderer is... Oh, hold on. We do a VK in it, but I don't think we ever actually attach it. Okay, I might have a clue on what's gone wrong here. Let's have a look at that, shall we? Git diff source main.c. I know I change a lot of stuff, but I'm looking for something around the bottom. Create window and renderer. SDL window is window. And then we just initialize Vulkan. I swear we're supposed to do something else there. That doesn't feel right. I'm definitely missing something important. Oops. Okay. Probably like Slate, SDL. Hey, look, renderer. Yeah. Actually, hold on. Are there SDL functions used in here? Oh, I use SDL freeze. That's interesting. That's fair, though. I'm using agnostic stuff that SDL provides me. Okay, I don't seem to create anything super SDL specific. Like, I create my instance, but there's no... Yeah, SDL mem copies, sure. Yeah, I'm definitely supposed to create a renderer, and I apparently just threw that code out the window. So, might want to do that. Create renderer. Create GPU renderer? Create software renderer. SDL VK Vulkan. SDL Vulkan. Create surface. Okay, hold on a second. Let me go to Slate. Nice one. Best to ever do it. Let me log into my Forge real quick. Because apparently this thing just does not store my details for more than 5 seconds. Now would be an inopportune time for my Bitwarden vaults to be down. Why can't I see any of my stuff? Okay, when in doubt, desktop app, I fucking guess. Login as Ari with that. Oh, security key. Yeah, you betcha, pal. You bet your bottom dollar. All right, source. Main.c. I want to check the blame on this. When did I go changing shit around here? Ooh, 1 moment. I'm back. Okay, create window and renderer. Add early software renderer. Oh, this was definitely this definitely caused problems. It would have been here when I would have been deleting Vulkan code without looking properly. Vulkan init. And seriously? Okay. Yeah. Create a window. And Slate Vulkan init. Okay. Huh. Was this really just in that awkward of a spot? I guess it was. Okay, tell you what I'm gonna do. For the time being, I'm going to just not have that flag, so I can actually show you where we're at, because that is what you're asking about, and I would like to show that. Mesa compile. Bingo! We got our little box here. Yeah, so our sounds are so good, Louder. You're not gonna believe this. Check this shit out. That's a 440 hertz sine wave if I've ever heard one. Look at that. Going into the sub area. Sounds clean. Got our triangle. That little buzz. Very nice. Our saw wave. It sounds a little weird when you go lower down because it's not like a super high resolution saw. Turns out it's very computationally expensive to make those. Look at that. Yeah, the filtering is probably the lack of resolution that I have. I need a more efficient way to calculate the saw and square waves is the problem, because I'm currently I'm running out of budget in my audio processing time. I need it to all happen in like less than a millisecond, and doing saw and square wave with too much stuff ends up making it take longer than that. Yeah, what was the fix? So twofold. If I don't think you were here for the part where it was like super weird and where we fixed it being super weird and choppy. The choppiness was right here. It was this. So it wasn't a buffer problem up here. I ruled that out in every capacity I could, but it was when we were actually sending that buffer data over to SDL. So it's supposed to be, hey, to this audio stream, send these samples, here's the amounts, is what I thought that meant, but this isn't the number of samples, this is the number of bytes in the samples you're sending over, because this is doing a mem copy, so you need the bytes, not the counts. So what was happening was, keep in mind, it's a 32-bit bit depth. Yeah, it's 32-bit depth. So if it's asking for bytes, and I'm not giving it the number of bytes, I'm essentially telling it, hey, only copy like a quarter of my actual sample buffer, and that's what was causing problems. Huge problems. We did have a timing issue after that. So it was playing at a way lower, I can get rid of that now. It was playing at a way lower frequency than I expected. And the problem was the math I was writing. So I've got this, there's a difference between M2 pi and 2 pi. 2 pi here is 2 over pi, but what I wanted in this particular part of these functions, hello? Oh, not math C, audio C. What I actually wanted was 2 by pi, not 2 divided by pi. And that was causing the rates to be completely off. So yeah. So you got rid of the by 10. Yeah. Thank goodness. Yeah, it was just silly math issues and silly passing in array length instead of array size problems. And then it works. So I'm delighted. I'm very, very happy. So yeah, audio is in a very good position. Couldn't be happier. I'll at some point maybe work on ADSR stuff, but what I really want to do, ideally, I want to see if I can wrap this up tonight and hopefully soon, because I got to go real soon. I would like to see if I could get my Vulkan stuff up to snuff. That'd be really good. Let's see if I can, because currently I'm running into big bad issues doing this, actually. Let's LDB that. Yeah, we just get like a Wayland window. I can't do anything with it. Well, it's not even a Wayland window. It doesn't give me anything. And I think I have a clue as to why that's happening. I guess I hadn't checked this at the time. But like, yeah, we create our window, but we don't create an SDL renderer. And I'm not entirely sure how we're supposed to attach the Vulkan renderer to the window. That's hopefully something I'm able to figure out here. I'd imagine I'd want to put it right after I've done initialization of both. Maybe it's like SDL attach? No. Some Vulkan thing? Presentation support? No. Guess I should probably check the documentation on this, yeah? Create window end renderer is not what I want, though. If you intend to use a window with an SDL renderer, you should use that instead of this function to avoid window flicker. Maybe I do need to create a window in renderer. Hold on. Okay, let's see here. Window size, that's fine. Ooh. Window usable with a Vulkan instance. Uh-huh. Window pixel size, that's fine. If the window is created with either of these, then the corresponding load library function is called, and the corresponding unload library is called by that. Okay. If you intend to use this window with an SDL render, you should use that. Do I need to? I'm not entirely sure how to plumb that together. Vulkan SDL attach, maybe? SDL Vulkan create surface. Ah, create a Vulkan rendering surface for a window. Window must be created with that flag. An instance must have been created with extensions returned by this enabled. Ah. Okay, that'll probably still fail for now. Because... oh my god, I'm scrolling in the wrong place. Create instance. When I'm getting my extensions... was it required extensions? Yeah. I need to, like, pass in more extensions. Instance extensions, though. Tell you what, let's do SDL gets... ah, damn it. SDL Vulkan get instance extensions. Yep. Okay, that's going to return me the count. Okay. On return, the variable pointed to by count will be set to the number of elements returned. Suitable for using with create info enabled extension counts. Okay. I might just be able to use this then. Tell you what, we'll do that. Wait a minute, instance extensions there, and then VK instance extensions? Oh, it's the ones supported by Vulkan. And then we compare them. Gotcha. Okay. So what I should be able to do is drop this in, set this to... oh wait, and SDL extensions. Wait, do we do this already? Oh, we literally do this already. Okay, no, that's not a problem. Okay, great. So it has been created with those extensions. That's perfect. No sweat off my back. SDL Vulkan create surface. Should be good. Slate, SDL window. And we're going to have our Vulkan instance. So that's going to be Slate VK instance. We do not have a custom allocator. And I guess we need Slate's VK surface. Awesome. Or not. Oh, right, because we... wait, we were creating our own surface. Do we need to do that anymore? Oh yeah, it's like the second thing that we do. Oh hey, what do you know? Oh shit, we do this. Okay. Fail to create windows. Well, yeah, that doesn't seem to fail. Ah, balls. That's really annoying. What if you calculate the full length of a frequency at the given sample rate, cache that, and then just read from there to just copy into the buffer? So like, oh yeah, caching it. Certainly an approach. It would be very limited, so like I wouldn't be able to do polyphony very easily. At all, basically, if I'm just caching that. ADSR would be possible still, but tricky. Yeah, it ain't perfect, but I get where you're coming from. Depending on what I'm doing, it would actually be very useful, but because I still want to be fairly dynamic, it would probably be more hassle than it's worth. Yeah, I could change amplitude, but again, like, polyphony wouldn't work, and that is something I do want to support. If I end up doing anything else with that audio, a lot of that caching kind of goes out the window, I feel. I get where you're coming from, though. Yeah, maybe it is doable. Could investigate that some other time. Right now I'm working on rendering. Interesting. Oh, wait. I know why that isn't working. It's because the Vulkan render isn't done yet. We haven't finished cooking it. Yeah, we're not actually drawing any frames. There's nothing to present. Render. Yeah. Yeah. Okay, that's fine. Let's try and blitz through the last of this then, I guess. So that I can get her going. Wait, we got command buffer, record command buffer. There's a whole thing as well. Let's put that actually into our... Oh, that is already a thing. Did I not have another thing in here? Oh, I did. Right, yeah. We were translating this. I'm reasonably happy with most of the variable naming here. This is okay. That's going to be VK image memory barrier 2. Wow, okay. I think that's maybe valid. Swap chain images, that's going to be... Yeah, swap chain images image index. Hold on. Oh, right. Gotta actually have Slate in here so I can work with this. VK swap chain images and image index. Cool. We're gonna have VK probably gonna be like, yeah, hold on. VK image aspect flag bits. Max enum? What? Okay. That's weird. You don't seriously mean that's all you've got, right? VK image aspects. I guess it's probably the color bit, right? Aspect mask. Ah, yeah. Cool. It's color bit. Or stencil, or whatever the hell else I want. Ain't that nice? Cool. Yup, that's a normal fucking thing. Whole bunch of stuff. Okay. VK dependency info has that stuff in it. And ordinarily I don't really copy paste like that, but that was just a lot of shit and that would have been really annoying to write out. So I'm allowing myself to ignore it. Command buffer pipeline barrier 2, that's going to be VK command buffer. Oh, wait, no. VK pipeline. Whoops. Fuck. Oh, wait, no, it's lowercase v for functions. Pipeline barrier 2. Okay, that's not a thing. Cool, gonna have to pull up docs on that one. Pipeline barrier. VKCMD. Command pipeline barrier 2. Dependency info. Gonna need to be a pointer, I presume. No, it is not happy yet. Oh, right, because we have to actually pass in. Right. Slate VK command buffer. Cool. Okay. So that's, I guess, a command, I presume. And it's transitioning. Okay. Oh boy. Yup, there's some stuff in here. All right. Excited to barely utilize any of that functionality. Starting dynamic rendering. Are we just doing this anyways? I guess. I mean, we're so close, right? Okay. Yeah, before we start rendering, transitional swap chain image to color attachment optimal. Okay. We'll slam that in here. Slate VK transition image layouts. Pass in slates. What image index exactly? Oh, right. That's just gonna be... Well, okay, in that case, I probably don't actually need that. Or you just do slates VK... Wait, do I not have an index? Hold on. Perhaps I don't have a swap chain image index. That seems like that might be important. Is that something I store? Oh, I just realized now I can make this dark. That'll make my life a bit easier here. I reckon you could probably save 80% even with polyphony. Yeah. If it's the same, or even just, yeah. We cache it on the instrument level for that voice or something. Yeah, on the instrument voice level, cache it there. That would make sense. It would, yeah, I think I could see where you're cooking. It would just take me a while, so I don't feel like doing it right now. Let me finish off this food. All right, all done. Let's go. Oh. Okay, never mind. I guess we are given the image index at some point. Or we get it from somewhere. With dynamic rendering, we don't need to create a render paths or frame buffers. Instead, we specify the attachments directly when we begin rendering. Okay, I'm gonna guess that the image is just something that I swap between. So, swap chain index, I guess. We'll call it image index. Because that is going to be important. That seems very much like a stateful thing. We'll just start with 0 and just like see how it works. VK image layout undefined. Cool. And then we get color attachment optimal. Nice. Source access mask. You have left that blank, I guess. Okay, can I just make that null or 0? Sure, I guess. Okay, access flag, color attachments. Oh shit. Right. Color attachment right bits. And then pipeline color attachment outputs. Not getting what I'm looking for here. Not ideal. VK pipeline stage flags. Tool purpose? The fuck? Color attachment outputs. VK tool. Wait, VK pipeline. VK flag 64. Oh, that's not particularly clear, is it? Oh, wait. Pipeline stage flag bits. Aha! Here we go. Pipeline stage 2. Oh, color attachment output bit, KHR. Bingo! That's what I want. Where am I going again? Down here. I went the wrong way. Genuinely, where am I going? Okay, cool. This is where I wanted to be. That is fine. Let's paste that in there. And paste that in here. Cool. Let's tidy this up a little bit, because this is like kind of ugly right now. And by kinda, I mean like a lot ugly. It's real bad. Great. And right, yeah, you need Slate still. Great. Okay, transition image layouts. I can't remember. Does this have a possibility to fail? I think this would, right? Oh no, it's a void. Ah, it's free. No error checking required. Let's go. Very happy. Cool. All right. Okay, we transition the image layout to color attachment optimal, then we set up the color attachments. All right. You put this somewhere, didn't you? Yeah, you know, we're gonna leave this kind of loose here because I'm not 1,000,000% sure what's supposed to go down with this, but the moment I know, I'm gonna put it into a nice tidy function because I'd rather this not be super ugly. I'm gonna use the correct spelling of color. I say that like we were like fucking forced into that by colonial powers, like be so for real. Do I have another form of like color value in here? Make a clear value. Okay. You've got color and depth stencil. Oh. Uh-huh. Yup. Mm-hmm. Can I just do this maybe? Will that make you happy? I really hope that makes you happy. Okay, attachment info, swap chain image views, image index. Yep, been here before. Start with 0. Actually, hello? My music player just crashed? On God? Just like that? No, it just paused. Oh, it must have accidentally hit the button or something. Weird. Image index. And I just realized that is wrong. That's supposed to be VK swap chain image views. And this would be, yeah, VK color attachment optional. VK color attachments optional. Oh yeah, for image layout. That's fine. VK load clear and VK load store. I assume that's valid? It's not valid. Store up. Ooh, yeah, makes sense. Wait, clear? Yeah, that is what it says. Well, that's a bit confusing. I work on this with someone else? No, that's just a habit I'm trying to develop because I feel like that's good for this kind of stuff. Okay. Hopefully that just works. Though I suppose in the future, if I do end up working on this with other people, it doesn't hurt to annotate like this. Again, good habits. The image view parameter specifies which image view to render to. Image layout specifies the layout the image will be in during rendering, which is color attachment optimal. The loadout parameter specifies what to do with the image before rendering, I guess clear? And the store parameter specifies what to do with the image after rendering. I guess we're just doing clear just for the sake of getting a screen. We're using clear to clear the image to black before rendering, and then store to store the rendered image for later use. Oh. So it's like we're pulling in with clear, and then we're gonna store that. Okay. I'm sorry, I understand. To-dos and source code comments never get lost. Clear the best place for them. Has never spent 12 hours trying to find out which code base had his grocery list. That's an obsidian. Both are good. All right. Rendering info. I'm gonna... Actually, you know what? Hold on. I'm gonna change this slightly. Let's do this. Like that. There. Prefer that syntax a lot more. So we're going to do our rendering info next. Is that rendering info? Cool. We'll do rendering info. That's going to be initialized to nothing. Nothing? That's right. Nothing. Rendering info dot. Start with render area, I suppose. Ah. Okay. Yep, this is gonna take me a sec to write this out. It would seem. Is that an int? It is an int. Okay, just had to make sure. And extent we would actually have. Oh, well, I guess it's swap chain extent. We do have that somewhere, right? Oh, we do. Well, ain't that nice? I wonder, can I do this actually? Yeah, I had a feeling that wasn't going to be valid. That's fine. Perfectly okay. Okay. Next, layer counts. Let me guess, 1? Yep. Color attachment count. And p color attachments is going to be attachment info, but a pointer to attachment info. Ah, begin rendering. Okay. Render area parameters defines the size of the render area, similar to the render area in a render pass. Sure. Layer count parameter specifies the number of layers to render to, which is 1 for a non-layered image. Color attachment count and p color attachment parameters specify the color attachments to render to. This is going to be so fun to figure out later. Now we can begin rendering. Like so. Or not quite, because it's a little bit different. You know what? Actually, what's probably supposed to happen is this is probably supposed to go in the rendering loop. I'm thinking. Yeah, so definitely make sure that transition image layout is exposed. Bingo. Just yoink that. Drop it into the header. Yup. That's wordy. That's fine. Oh, for goodness sake. I know that's failing. It's just annoying. I got render. Oh. Oh, for God's sake. Okay, that's fine. You are complaining. Why? What's your problem? File not found. Oh, right. That'd be it. Okay, Vulkan VK. Oh, come on, man. Am I on another fucking planet or something? Oh, no. Cool. VK. Transition image layout. There it is. Okay. VK. Let me guess. Oh no, we have Vulkan H included. Okay. I'm not sure why it's not giving me complete for this. Oh, well, there it is, I guess. Oh, it's supposed to be lowercase. begin rendering. Yes, yes. Okay, what am I supposed to have? Command buffer. And our rendering info. A pointer, to be exact. This shouldn't error. Okay, all the functions that record commands return void, so there'll be no error handling until we finish recording. Yes! Parameter for begin rendering command is the rendering info we just set up, which specifies the attachments to render to in the render area. Okay. So we do have stuff. Are we doing triangle percent already? Okay. Although, hold on. Yeah. So there's a draw command here that just says, oh, vertex count and whatever, but when did we upload that data to Vulkan? Graphics pipeline, we create our shaders. Shader modules, we have our viewports, rasterizer, all of this stuff. I guess we have this, but... Oh wait, did we not do all this now? Code attachment, rendering info, begin rendering, end rendering. Oh no, I think we skimmed this. I probably shouldn't have done that. Wait, hold on. Record command buffer. Command buffer begin. Color attachments. Rendering info. Begin rendering. Oh. Oh. That's all this stuff. So let me go back into here. And so that is in create graphics pipeline. Can I just do that here? Is that... This seems a bit early, no? Yeah, no, that should absolutely be in its own record command buffer. Okay. Oh, wait, yeah, no, that is that function. Record command buffer. Ah, here. Okay. Okay, yeah. I thought something was off there. Transition image layout. Okay, so that just needs to be defined sooner then. That's perfectly okay. Awesome, great. So we have that, and begin rendering with our rendering info. We end rendering. BK end rendering. And pointer to rendering info. No, not a pointer to rendering info. Just, yeah, right, of course. Render commands here. Cool. Okay, this is making sense now. Gotcha. Okay. Transition the image layout for presentation. And that's image index again, I guess, right? Never exactly change it. Transition for rendering, and then for oh, we're transitioning this image. Oh, my brain is growing massive. It's crazy. I'm getting so smart. Color attachment optional. Optimal. I keep misreading that. Going from optimal to VK presents KHR. Okay. VK image layout present source KHR. Yes, that is correct. Source mask. E color attachment rights. Yeah, that's that one. That is going to be 0. Source stage. Pipeline to use color attachment output bits. Yeah, it was. And the destination mask. VK pipeline stage 2. Damn it. End. Oh, sorry, no, end. Bottom of pipe. I imagine I want the Chronos variants. And again, that cannot error on me. That's good. Can this error? Nope. Cool. Right, because that's all like prep. And I think it's only when then ending command buffer. Yeah, VK results. So, Slate, VK, command buffer, and VK results. I guess VK results. Let me steal my existing code for this again. Do not like writing error handling code normally. Don't feel like doing it right now. Delightful. Failed to end Vulkan command buffer. And that's it. Okay. Now we can just start putting in commands. Okay. Holy shit. Okay. So VK command buffer. We have a lot of stuff here. Bind pipeline. This is gonna be slates, VK, command buffer, pipeline bind points, E graphics. You know what? That's what I'm gonna tell me here, or not. VK pipeline bind points. Graphics. And the pipeline is our pointer to our graphics pipeline, which I believe we have stored. Nope. Pipeline layouts? Nope. You want a VK pipeline, which I never stored. That seems a bit strange, doesn't it? That seems like something I would have wanted to store. We have our pipeline layouts. We create the layouts. Oh, is this where we're actually supposed to create the pipeline? Wait, no, because we did this. Okay. Ah. Did I just, like, skip that by accident? I might have. Graphics pipeline create info. Pipeline rendering create info? Oh, I must not have finished that part at all. Graphics pipeline create info. Yeah, what the fuck? Fix functions. How far back am I? Shader modules. Okay. Loading a shader, creating shader modules. Fixed functions. Pipeline layout. Ah! Pipeline layout create info. So I just did that. And then it strains to dynamic rendering. Okay. Oh, pipeline rendering create info. Okay. Sweet. Color attachment count is 1. Yeah, I think I'm gonna have to do this before I continue. Swap change surface formats. The fuck? What did that say? Oh, color attachment formats. Cool. I've noticed something here that's probably going to bug me later. Give me just a moment to figure that out. What is that pipe swap chain surface formats? That just goes in, yeah? Not quite. Not quite. VK formats. And what are you? VK surface formats. I don't store a VK format. Great. Swap chain surface formats dot... Oh. Haha. Of course. Yeah, this S-type thing, I've been neglecting that. That, I'm pretty sure, is very important. At least in C. It's like a big deal. So I need to do attachment info, S-type, VK structure type, attachments info, rendering attachment info, KHR for good measure. Same for rendering info. That might just be this, right? Yeah, figures. Cool. Should make my life slightly easier. Yep, S-type. Fucking knew it. I knew it. Image memory barrier 2, KHR. What is the difference between the KHR variants and the non-KHR variants? Nothing. They appear to be the exact fucking same thing. It might be some, like, weird legacy thing. I have no earthly idea. Oops. Did not want to do that. Okay. That's more like it. Dependency info, this still needs S-type as well. It just does not fucking read properly if I don't do this, so... This annoyed the shit out of me before. Thankfully, we have validation layers, which actually would have warned us about this, but I still don't want to deal with it later, so it's better to just take care of it now. Right, yeah, pipeline. Still making the render pipeline. Okay, cool. So that's sorted. We have our create info. And then what in the fuck? Oh, man. Graphics pipeline create info. BK graphic... Bro. Graphics pipeline create info. Pipeline rendering? Oh, yeah, because these are all create infos, right? Yeah. Start at 0 initialized, of course, as always. And graphics pipeline, S-type, VK structure type. If I could spell. Bro? Right, okay. Structure type graphic. Oh dear. Wait, what? Pipeline. Okay, that's not super convenient. Graphics pipeline shader groups create info. Graphics pipeline create info. It's right here. Why couldn't you autofill that for me, man? Okay. And what are we setting on this? Oh, so much stuff. You would not believe. Structure chain? I'm gonna try and ignore that. Oh wait, we'll include the structure in the structure chain. Is this a thing here? Okay, no, I think that's a weird C++ism. Gonna ignore that. Stage count is 2. Stages is going to be shader stages. Good, a thing I already had from earlier. That's delightful. P stages, P vertex input states is gonna be vertex inputs info. Input assembly states. Input assembly info? Probably a pointer, yeah? Yeah. Graphics pipeline. P viewport states. Viewport state info, also a pointer. Good grief, there's a lot of stuff. Rasterization state is going to be if I could type rasterizer? That appears to be valid. Yeah, rasterization state create info. Okay, cool. Oh yeah, we're just going down the whole list, I guess. That's fine. It's a whole big-ass pipeline. This is why drawing a triangle ends up being so goddamn easy, because so much stuff was done ahead of time. Rasterization states, multi-sample states. Did I ask, what's it called? Yeah, multi-sampling. Ah, I excluded this? I'm gonna leave that there. Yeah. I feel like it wants me to have that. Multi-sampling, color blend states. Color blending. Graphics pipeline. Dynamic states. Dynamic state info. And then the layouts. Pipeline layouts. I guess a pointer to it? No. Uh-oh. You're unhappy. VK pipeline layouts, which you are not, because that's that VK pipeline layout. Ah, right. It's the one we have in Slate's VK pipeline layouts. Bada bing. And then render pass, which is for some reason null. Sure. I'll accept that as it is. says graphics pipeline create info and then pipeline rendering create info. Oh, right, which has this stuff. Color attachments, the formats. Okay, sweet. Oh. Hey, we had that. Ain't that neat? Okay. So, I think I can just slap that on here. Wonderful. And there's probably going to be a funny little... You create this, right? We do create a pipeline, I would think. Pipeline render create info. Ow, my eyes. Okay. We're going to create info and then... Yeah. Pipeline create info chain. Grabs pipeline create info. Stage count. Oh yeah, and all that stuff. Yeah. Oh, right. Yeah, this is shit that I just fucking missed somehow. So you create a graphics pipeline. I suppose that's something we'll want as like a member in Slate H. It's just taking a shot in the dark there. Yeah, I got our pipeline layouts, and then we need VK graphics pipeline, or is it just VK pipeline? Yeah, pipeline. And then in here, graphics pipeline. Well, hold on. Oh yeah, because that's our create info for that. Yeah. VK creates graphics pipelines. Interesting. VK device pipeline cache. Do we have one? No, we don't. So that becomes null. Why can't I tab anymore? That's why I can't tab anymore. I somehow tabbed its OBS. Create info counts, we just have one, I believe. I guess one? Yeah. Oh, and then the create infos that we have. VK graphics pipeline create info, that's gonna be graphics pipeline. And it wants a pointer to that. Allocator, gonna be null. And then our pipelines. Ah. Cool. Can't help but notice that this doesn't really get used at all. Is that right? What is with the chain here? That doesn't make any sense to me. Okay. Note that we're using dynamic rendering instead of traditional render pass, so we set the render pass parameter to null pointer and include a VK pipeline render create info structure in the chain. Ah, I think I understand what's going on here. I'm probably supposed to do a pnext. Yeah. And that goes to pipeline rendering. That is what I think that chain is supposed to do. I vaguely recall that API functioning that way. Cool. Then chuck that on here. VK result is that, and if it fails, fail to create Vulkan pipeline. Awesome. So assuming that worked, we have a graphics pipeline, which means we can then proceed with our transition image. Yeah, transition image layouts. Pipeline barrier. It's in record. Yeah, because this is still failing. And then we just pass in pipeline. Bada bing. That's just a regular VK pipeline. All good. End rendering. You are unhappy because I forgot a semicolon. My bad. My bad, slime. Okay, we bind the pipeline. Command buffer set viewports. Slate's VK command buffer. First viewport is 0, I guess. Hold on, what? First viewport counts, and then the number of viewports. Uh-huh. Right. Do I just have this stored, don't I? I don't. Unless I've got a viewport sitting around here somewhere. Swap chain image views. That's VK image view. No, that's a handle. I guess I have this. Yeah, this isn't great, but like it'll work. Okay, I don't have to do S-type with this. Yeah, that's pretty straightforward. What I might even do here, this is one of those cases where I might actually use this format or this style for writing out the parameters here. Yeah, just because I can compact it then a little bit. It's a bit nicer. Okay, so we set viewports. I think that's fine. Swap chain extent. Oh yeah, this is like the exact same dimensions. That's fine. Okay. We gotta set a scissor as well. And of course it is much the same here. Yup. Have to actually define a scissor. I think. Oh, just a rectangle? Yeah. Mm-hmm. Offset is... We'll drop this down here, actually. Our X is going to be... Was that an int? That's an int. So offset is this. And our extent, right? Yeah. That can just be, yeah, slates, BK, swap chain, extents. Beautiful. Very nice. Now we are ready to issue the draw command for the triangle. Why can't I do multiple of these, by the way? First scissor 0, scissor count that, and then... Yeah, fascinating. I do not understand why that is the API for this, but whatever. And then a draw command. Ain't that exciting? Our command buffer. Vertex count, we're just going to say 3. Instance count 1. First vertex 0. First instance 0. I guess you can do by an offset. That's probably it. Okay. And then we end rendering. After rendering, we need transition and then end the command buffer. Now, I don't remember ever uploading stuff to this, so that's interesting. Yeah. Oh, right, vertex buffers. Oh god, yeah, there's so much more. Oh boy. Okay. Let's see how quickly this can go by. Outline of a frame. Okay. At a high level, rendering a frame in Vulkan consists of a common set of steps. Wait for previous frame to finish, acquire an image from the swap chain, record a command buffer which draws the scene onto that image, submits the recorded command buffer, and present the swap chain image. That makes sense. Synchronization. Core design philosophy in Vulkan is that synchronization of execution on the GPU is explicit. The order of operations is up to us to define using various synchronization primitives, which tell the driver the order we want things to run in. This means that many Vulkan API calls, which start executing work on the GPU, are asynchronous. The functions will return before the operation has finished. Sure. In this chapter, there are a number of events that we need to order explicitly because they happen on the GPU, such as acquiring the image from swap chain, executing commands to draw, and presenting the image to the screen for presentation. That makes sense. Each of these events is set in motion using a single function call, but all are executed asynchronously. The function calls will return before the operations are actually finished, and the order of execution is also undefined. That is unfortunate because each of the operators depends on the previous one finishing. Thus, we need to explore which primitives we can use to achieve the desired ordering. Oh my god. Okay. Semaphores. A binary semaphore is used to add order between queue operations. Queue operations refer to the work we submit to a queue, either in a command buffer or from within a function, as we will see later. Examples of queues are the graphics queue and the presentation queue. Okay. Semaphores are used both in order to order work inside the same queue and between different queues. There happens to be two kinds of semaphores in Vulkan, binary and timeline. Because only binary semaphores will be used in this tutorial, we will not discuss timeline semaphores. Further mention of the term semaphore exclusively refers to binary semaphores. Is this a mutex? Binary semaphore is either unsignaled or signaled. It begins life as unsignaled. This sounds like a mutex. This really sounds like a mutex. We queue A with signal S. Wait, none. That's an interesting one. Can you do like VK queue submits? What does that look like here? Can we only do fences? Ah, shit. Well, maybe a fence is what we want. Fence is similar purpose in that it is used to synchronize execution, but it is for ordering the execution on the CPU, otherwise known as the host. Concretely, if the host needs to know when the GPU has finished something, we use a fence. Okay. Similar to semaphores, fences are either in a... Okay, there's different types of mutices. That's fine. Whenever we submit work to execute, we can attach a fence to that work. When the work is finished, the fence will be signaled. Then we can make the host wait for this fence to be signaled, guaranteeing that the work is finished before the host continues. A concrete example is taking a screenshot. Say we have done the necessary work on the GPU. Now we need to transfer the image from the GPU over to the host and then save the memory to a file. We have command buffer A, which executes the transfer, and fence F. We submit command buffer A with fence F, and then immediately tell the host to wait for F to signal. This causes the host to block until command buffer A finishes execution. Thus, we are safe to let the host save the file to disk as the memory transfer has completed. Okay, it's not exactly a mutex, but it serves a very similar function. It's a lock operation sort of deal. It's just kind of an inverse. We're waiting for the flag to be raised before we actually proceed. That's very reasonable. Queue submit counts, stuff we're submitting, and then a fence. Okay. That API is pretty straightforward. I don't have a problem with that at all. Device wait for fences. Okay, yeah, so I've got like VK wait. Hold on. VK, wait for fences. Yep, there it is. Cool. Oh, and we can timeouts. That's useful. Imagine a render takes like 100 seconds. And it's like, yeah, that's not good. That's really bad. Unlike the semaphore example, this example does block host execution. This means the host won't do anything except wait until execution is finished. For this case, we had to make sure the transfer is complete before you could save the screenshot to disk. Well, that makes sense. That's a fair blocking operation. Where'd you get the idea to make your own engine? What resources are you using? I got the idea to make my own engine from being a huge fucking nerd and not liking magical things. In the sense that I don't like things being black boxes to me. I look at games that I enjoy playing, and I can enjoy the games, but there is a part of me that goes like, yeah, but like, how does all this stuff work? The way I see it, like, every single thing that my computer does was made to do so by a human, and I am also a human, so I should be able to do those things. Why not? It's kind of a very cocky attitude towards software, but it's also like, it's a great learning experience. That's the main reason. I have more of a, put it this way, I have more of a willingness to learn than I do an idea for a game I would actually make in this engine. But yeah, thank you. It's really not much right now. Like, I'm working on getting the Vulkan backend running, so we don't even have a triangle on screen just yet. If I'm following a guide or something, I'm following the Vulkan documentation. Other than that, I followed a variety of other things in order to make this happen. Like, I recently was doing some audio synthesis stuff just because that was cool, and I followed a guide from One Lone Coder to... Now, I've deviated quite a bit. I implemented my own API around this whole thing, but a lot of the principles are something that I picked up from his videos. They're very cool. Do recommend. It is badass. It's super cool. Okay, I think I get the idea. What to choose? Well, I don't think I have the option to use semaphores, so... Yeah, this is like queue submits. And that's kind of it. Unless there's... Yep, nope. Only fences. Do we even have, like, VK semaphore? Oh, no, we do. That's interesting. Why? Do that, please. Can I find your reference? Are you used anywhere here? VK submit info. Ah. So we can use semaphores. Okay, so that is actually important then. We have two synchronization primitives to use and conveniently two places to apply synchronization. Swap chain operations and waiting for the previous frame to finish. We want to use semaphores for swap chain operations because they happen on the GPU, thus we don't want to make the host wait around if we can help it. For waiting on the previous frame to finish, we want to use fences for the opposite reason, because we need the host to wait. This is so we don't draw more than one frame at a time. Because we re-record the command buffer every frame, we cannot record the next frame's work to the command buffer until the current frame is finished executing. We don't want to override the current contents of the command buffer while the GPU is using it. So both. Funny. This is great. That's fantastic. Okay. Okay, yeah, of course, they're class members. Yeah, I had a feeling we were going to go there. Hooray for buffers! I think I'm gonna have to... I was supposed to, like, wrap up 6 years ago. I am probably going to need to head really soon. Say present complete. Render finished. And draw fence. Cool. There's something I should be doing here that I am very much neglecting. Let me go into here. I'm gonna use the SDL mem sets in this case. I'm gonna set to 0 and size of slates. Let's just make sure there's absolutely no chance of there being garbage data in here. That'd be nice. How does one make a game engine? Time and effort. You have to build a lot of stuff from scratch, like how stuff gets drawn on the screen and how sound gets to your ears and how input is handled and how windows are created and how networking works, everything. It's a lot of time and effort and a lot of learning, and that's what I'm doing here today. I'm basically learning how does one make a game engine in real time when you think about it. May I ask also, why Vulkan and not something OpenGL? Vulkan is more modern and more powerful. That's the most of it. I could use OpenGL and I would have had a triangle on screen 6 years ago. But yeah, Pikunico OST. I still have yet to play the game, unfortunately. It's on my list. I very much intend to play it, but I have a large backlog of other games I want to get through first. Yeah, it's so good. Oh, that's interesting. Okay. We create our sync objects as its own whole thing. Slate error. Slate VK creates sync objects. Slate. Cool. Maybe this just doesn't even return an error. Who knows? Takes a while, like 3 hours. Oh, real? Shit. Might just be a stream or two then. Awesome. Or just pick a Saturday. I like that you try such a task. What IDE is that? I've never seen it. This is NeoVim. It is a command line text editor that I have roided out. Like, NeoVim does not look like this out of the box. I've had to do a lot of customization to get it to where it is. Do not feel obligated to do the kind of shit I'm doing. If you're on Linux, pick up something like Sea Lion. If you're on Windows, pick up like Visual Studio, maybe. That's what I would recommend. Sea Lion, I think, is the most cross-platform. Code Blocks, actually, because that's open source. Yeah. Sea Lion, Visual Studio, or Code Blocks. Either of those. They're fully featured IDEs, and they are easier to get into than NeoVim. I much like the reason I'm doing a game engine, I use NeoVim because I'm a huge fucking nerd. I've just gotten very comfortable with it. There's a lot of ergonomics in here that allow me to do stuff pretty quickly. Assuming I have control over my keyboard. I don't always. It's like a VK create semaphore or something? Oh, yep, sure enough there is. Create info. Oh, of course. Yup. VK semaphore, create info. I guess it's just empty, yeah? Okay. Semaphore create info is going to be empty. Yeah, I learned OpenGL in uni and I made awesome teapots. Fuck yeah. I use code blocks since the book I have told me to do so. Yeah, it's a fair choice. Was about to say only bad thing with Sea Lion for beginners is that it's paid, forgetting that it's not the case anymore. Yeah. I look, you need to make the change to Linux. I've been thinking about switching to CachyOS. I've heard some good things about CachyOS. I've heard some complaints, but like nothing specific. So, you know, take that with a grain of salt. Everyone's got something to complain about with their operating system of choice. I love Linux, and even I would have stuff to complain about. Which one is this supposed to be? Present complete. And that better not have error handling that I need to deal with, or I'm going to be very upset by that. Oh, it does return a VK result. Are you serious, man? Oops, I did not mean to undo all of that stuff. I probably need to store that. There we go. Triangle incoming. I don't know about tonight. It looks like we still have a lot to do here. I don't even have a vertex buffer created. But tell you what, I will be here Saturday if you are available. And I will be doing more work on this engine then. And that's a very good time to catch me because I will be up basically all night at that point. Cool. Fails Grave Vulcan Semaphore. Oh yeah, I probably need to set the S type on this, don't I? VK structure type oh, really? Oh, man. You're killing me. VK structure type semaphore. Huh? That's not a structure type. Oh, yeah. Structure type creates info. Right. How could I be so mistaken? It rolls off the tongue. VK structure type semaphore type create info KHR. Of course. Of course. My main concern is getting games to work, but from what I understand, that one just works. Gaming is like so solid on Linux and it gets better every day. I wouldn't be too concerned. Any game that doesn't work on Linux is a game that has been like specifically designed not to work on Linux at this point. Like it's an antagonistic relationship, but at that point I would question whether you want to support that game. If they just like hate their users that much. It's very hard to distinguish your accent. Where are you from? Ireland. But I do have a very American twang to me, so I don't blame you for not picking that up. Render finished. Cool. I'm pretty sure I could just reuse that semaphore. I don't see why there'd be a problem. VK create fence. Now I need fence create info. I'm gonna assume that's blank as well. Oh shit, no, we do have something. Huh. Oh, not flag, fence. It's like your day on the bottom right doesn't look American to me. Oh, certainly not. Try to be here Saturday then. Got a big trip coming up, might not make it. Ah, that's fair. Hope you enjoy it. Whether I make it, best of luck, because I see how it turns out. Thank you. If you do want to catch up, I do upload these VODs 24 hours after. youtube.com/@remelodylive. And you can go there and you can watch. So like this stream will be up if you want to catch up with the stuff I did earlier. Saturday stream will be up, you know, the Sunday following. And yeah, you can just hop on. Shrimple as. Huh. I assume I want this. Probably. That's what I'm thinking. Oh, you're heading to bed. All right, have a good one, dude. Thanks for stopping by. Do all the major anti-cheats work on Linux? See, I've not worked with them very much, so I actually don't know exactly what the story is with that. I know easy anti-cheat can work, if you, like, enable it to do so. I don't know if it's by default. Yeah, I'm probably not the best person to ask about that. I don't really know, unfortunately. But I have seen games that have anti-cheats that do work on Linux for what it's worth, so. Depends on what you count as major and what you count as working. Yeah. Okay, cool. We have our sync objects. There's still a lot to do here. Oh my god, wait. But that's a triangle. Do we do it? Oh, man. That would hurt me so bad if I wasn't able to do this. Okay, I'm gonna try and, like, blitz through this as fast as I possibly can. Okay. Fence result, wait for fences. Okay. That's gonna be this. We have... Oh, wait. That's supposed to be device. My bad. Fence count is 1. That's going to be a pointer, 2 slates, VK, draw fence, wait all? I mean, I guess, right? Yeah, VK true. Timeouts, UN64 max. I mean, sure, why not? That can return a VK results. So I have to handle that now. That's great. Steal some code from here. Cool. Let's wait for drunken Vulcan draw fence. Bleh. Okay. Fail to wait for fence. Device reset fence. Reset fences. Oh, you also return a... God damn it. Now, like, I really don't need to be checking for all of these errors. The chances of these things failing are so goddamn slim. But I also don't believe in ignoring errors. I think that is a fool's errand. I do think that the ergonomics of this could be phenomenally better.
It's time to drink water.
Thank you, C.
It's time to drink water.
And indeed, it is time to drink water. Yeah, you know the deal. If you have water with you, you should drink it. And if you don't have water, you should definitely go get some, because water's good for you. Good ass water. Alright, cool. Cool, so we wait. We acquire the next image. Okay. VK device. VK swap chain. Probably UN64 max if I had to guess. Semaphore. Present complete. Oh, dereferenced? Huh. Present completes, that's what it is. And no fence? Okay. Oh yeah, and we're acquiring that into this. That's our next image. Ah! Hey, so we do actually find out what that is at some point. Isn't that wonderful? I was worried about that. I was worried I'd have to keep track of that myself. Nope, Vulcan has got us covered. Let me just drop these onto new lines so this is like even remotely fucking readable. Good. You're probably going to return a VK result, aren't you? I would be so surprised if you didn't. You seem absolutely like something that could just throw an error. Cool. Failed to acquire next Vulkan image, and yep, you do indeed return that, so good thing I checked. We're gonna have to split this into separate render functions depending on what I'm doing. For sure. Amazed by your mic quality. Which one do you have? This is a Shure SM58. S-H-U-R-E SM58. I have it plugged into a Focusrite Scarlett Solo. Do all that and you basically have my setup. That's my whole mic chain at least. It is not super cheap to get all this though, so, you know. Be wary of that. Okay. First parameter specifies the time in nanoseconds for image to become available. Yeah, we're fine. Like how they say using maximum 64-bit unsigned integer means we effectively disable the timeout. Yeah, if we're comfortable waiting like millions of years, probably it'll tick over, but that's about it. Okay. Yep, we use the index to pick a frame buffer. Great. And then we record a command buffer. Okay. At long last. I just pass in Slate. And we don't actually need to provide anything else because Slate has our image index. So that's all fine and well. Yeah. And this is going to complain because the function signatures don't match anymore, but that is a-okay. We don't need it there either, so we'll fix that. Transition image layout, we don't need that because Slate has it for you. Beautiful. Oh, we do still have an error though. Ah. That'd be that. All good. All good. And this can return a Slate error, right? Yeah, that can return error. Wait. I just realized something. Oh wait, no, I am actually storing the value of that. So that's, yeah. This one, I can just check if it is not equal. Oh my god. If not equal to Slate success? What is the positive code that comes out of this? Slate error, okay. Okay. So if it is not that, well, we already dump an error out to console, so we'll just exit if that fails. Wait, destination stage mask. Oh, fucking hell. This is something. Definitely gonna need to make abstractions here. I've asked way too many questions for my time being here. Nah, you're good, you're good. If I can answer them, I will answer them. I have no qualms. VK Popline stage flags. Wait, destination stage mask. VK. Well, okay. Probably have to fix these first. VK color attach. Okay, that's not great. VK pipeline stage. Okay, I don't have a clue. Color attachment outputs. I've seen this so many times before already. Here you are. Okay. And then we have a VK submit info called submit info. I'm going to start that as 0. And submit info S type. Probably going to be some bullshit like VK structure type. Submit info. Yup. Submit info, wait some for counts. Cool. Let's just try and fix these up nice and quickly. Submit info. There we are. Is software engineering your job, or is all this a hobby? It is my job and a hobby. I'm actually very delighted I can say that. I'm very recently a full-time hire at a software company, so yeah. I don't do game development there, though. Very much not so. Is this the present semaphore? Yeah, it is. Present complete. Yeah. Await destination stage mask. What was this? Oh, right. I see. Is this just like literally just flags? Okay, it's literally just flags. That's fine. So I can just set that to be equal to this then. I was thinking that was weird. I don't like the name on this though. Wait, destination, stage mask. Whoops. Paste over that. Command buffer count. We're gonna have pointer to Slate's VK command buffer and render finish semaphore. That's gonna be a pointer to Slate's VK render finished. Delightful. Yeah, pointer dereference whatever is cursed. Very fucking weird. Not an API I would have chosen, but that's C++ for you. I think they only cover C++ in this guide because it's like what all the game devs are using. They're using C++ generally speaking if they're going lower level. Like if you're running Vulkan anyway. But even their documentation shows C convention. It's like I can refer to the docs and get pretty good answers to questions about specific API details. It's weird. Don't know why it is the way it is. Yeah, okay. I have an idea of what these do. That's fine. And then Q submits. Right? Yes, Q submits. VKQ. I guess graphics queue? Oh. Submit info. Yeah, I'm gonna guess the queue is our graphics queue. I'll probably rename that to queue. Maybe. Yeah, we'll do that. It's gonna make some stuff here very upset. Cool. That's hopefully fine and not gonna cause problems. Okay, VKQ, submit count. I guess you just have one. and then a pointer to submit info, and a pointer to our fence, which is our draw fence. Not a pointer. Really? Oh, I guess it's already a reference, right? Bit random as a first message, but do you see at your job too, or is that a hobby thing? Oh, it is totally a hobby thing. I write like Java at work right now. Both have their pleasant moments and their not so pleasant moments. Yeah, I know. Believe me, I know. Would be nice if I wrote C at work, but that's not usually how you end up with super stable software. I do C at home because it's a fun hobby. Would you like an interface to your Hello World factory? Statements dreamt up by the utterly deranged. This section is optional and far more explicit than is necessary. Boop. The last step of drawing a frame is submitting the results back to the swap chain to have it eventually show up on the screen. Presentation is configured through a present info KHR structure at the end of the draw frame function. Sure. I swear I've done this before. I guess I've not done this before. Okay. Cool. You know the deal. We're gonna zero initialize that shit. Oh, people noticing my drive names. That's funny. Oh, sorry, I missed that. I know this question might be annoying, but as someone who just freshly got into software engineering, what's your thoughts on the future, including AI? Oh boy. Damn. I've never actually been, like, asked that candidly on Twitch, I don't think. I've certainly had my thoughts about AI. My immediate thought is not a big fan. I like writing the code. I have experimented with it. I have had to do it for work. I've had to do it for various reasons. And it has regularly let me down, to be honest. And maybe that's just because of the way that I write code. I don't know. Maybe it's the more unique problems that I get into. But that's also like part of the problem. Like, it can't handle those more unique problems. The whole deal with AI is it is trained on... It's trained on a bunch of stuff that people have already done, right? If you're doing something that nobody has actually done before, or very few people have actually done, it's unlikely to help you pretty much at all. And it really quickly becomes totally, utterly useless. And that has been the majority of my experience with it. So, like, considering I keep running into that situation where it ends up being more of a disappointment and a distraction from actually getting the work done, I'm personally not too concerned. As for exactly what advice to get around it, I don't know if I'm exactly the person you want to be asking for advice on how to navigate that, because I'm kind of just coasting. I'm coasting with the knowledge that I get into so much shit, I end up doing so much stuff where there will kind of never not be something that I can create that has the like AI wouldn't be able to hold a candle to. Just because I've been learning to create things for most of my sentient life, you know? Yeah. This is kind of the most I can say, at least at this hour. It is quite late here. I am going to be wrapping up very soon. Is what I said like an hour ago, but I'm so close to the triangle. I actually think this is it. Hold on. What is this here? So one last optional parameter called P results allows you to specify an array of VK result values to check for every swap chain if presentation was successful. It's not necessary if you're only using a single swap chain because you can use the return value of the present function. Aha. Okay. Just VK presents, right? Or not. It is not that. VK presents. Function somewhere, maybe? No function. That's alarming. VKQ presents, probably. Yep, that's it. Slate's VKQ and our presents info. Ain't this exciting? We might actually have a fucking triangle by the end of the night. And if we do, that is where I'm going to be ending it off, because I need to sleep. Failed to present Vulcan frame, I guess. Oh, man. What are the chances, right? Here we go. No, I got a bunch of validation errors. Okay, well, let's have a look. Multi-sample state creates info. Rasterization samples is 0. Okay. I already know where this is. Yeah, this was something that was kind of deliberately left empty. This was under the pipeline. Multi-sampling. Oh, there's a whole thing here. Sure, okay. Okay. Yeah. Multi-sample. Create info. Rasterization samples. Needs to not be 0. Okay. Features, properties. MSAA, surely, right? Or I guess not. Oh, wait, no. MSAA samples is defined elsewhere, isn't it? Get max usable sample counts. Okay. Also not helpful. Okay, I'm assuming that's another function. Yeah, it is. Okay. Just gonna yuck that up here, I think. VK sample count flag bits, get max usable sample counts. Yep. And then we will get VK physical device properties. Right, I have to pass in a Slate object. Physical device. Ugh, yeah, we get properties. VK get physical device properties. There's going to be slates, VK physical device, and then our properties. Yeah, I definitely wrote this code elsewhere in this file, but whatever, we ball. Oh, thank goodness. At least I don't have to handle errors with it. That's nice. Okay, VK sample count flags. I can probably just say properties, to be honest. That's fine. Uh-huh. That looks a bit better. Ooh, what the fuck? Okay. VK sample count flag bits. I guess 64? Okay. Okay, I can work with this. Vim, my beloved. Let's see if I can do a funky macro here. So we're gonna go... Oh, damn it. I already messed it up. Go to beginning of line. VK. We capture that. We go here. And we do that. And hopefully I can just do this 6 times. Amazing. I fucking love macros so much, dude. This is what I use NeoVim for. It's those few moments where I save precious seconds. What a weird function. But yeah, sure, whatever. Cool, and then rasterization samples. That is from get max usable sample count. Cool. Okay, what else is it complaining about? Create info S type must be this. Sure. Command pool creates info. Ah, yeah. I knew I had missed some stragglers. When do I not? Wait. Pipeline rendering create info. What the fuck? Okay, let me have a look at that command pool bit again, because that is probably not right. Command pools, flags, reset command buffer. Yeah, okay, that was not going to work. So let's fix that. Cool. Contains flag, but yeah, okay, so I fixed, 2 birds, 1 stone. S type on the allocate info. Yep, go figure. Sweet. Fences. Huh. P fences 0 is VK null handle. That's not good. Oh, I know why that happens. We never actually created those synchronization objects, did we? Yep, that would be useful. Create sync objects, and you can return Slate error because you can error. Yeah, you can error in a bunch of ways. All right, here we go. Shit. That'd be why. Ooh, we got a window for a split second. Okay, well, what happened here? Okay, yet another thing where I'm missing S-type. Command buffer begin info. There, I was thinking I could just leave that empty. Oh, how naive I was. Any other crate infos here? That S-type is sorted, that one is. Pipeline barrier 2. Huh, what's your problem? Synchronization 2 feature was not enabled. Really? Okay. Wait, that's a VK command line. Command pipeline barrier. Ah. Synchronization 2 feature must be enabled. Where's my required features at? Okay, I wrote this extremely poorly. So let me just tidy this up real quick. Cool, so that's checking features. Okay. And what's the feature I'm looking for? Synchronization 2 maybe? Visible device. Yeah, that might be what I'm looking for. Features dot features, I guess. That's checking device features, but enabling a feature. Ah, I think this is where I actually enable it. Device features dot sync. Okay, so that's probably a Vulkan 13 feature. Synchronization 2, VK true. Keep that nice and happy. Color attachments. Okay. That is on rendering info. Color attachments. Image view was created with an image sample count. 1 bit, okay, which is not much the corresponding VK pipeline. Oh, 8 bits. Ah. Wait, there's VK get max usable sample counts? Is that what it's asking for? Or sorry, wait, no, that's in attachment info. Wait. Dot image view. Ah, that image. Okay, hold on. So I gotta see where these views are being interacted with. tricky one, this. Okay. Those are all the cases where that's used. Well, that's a bit confusing. Okay, hold on, let's read this fully. Rendering info color attachments 1 image view was created with an image sample count, which does not match the corresponding VK pipeline multi-sample state create info rasterization samples. Yeah, why would that be 1 bit? So the image view must be wrong. That's probably, yeah, create image views. Level counts. Let's double check that I created that at all properly. Image views. View type 2D. Swap change surface formats. Image aspect color bits. 0101. Almost seems fine. What the fuck is this? Image view components. I see. I don't recall doing that, so I imagine that's important. VK component. VK component swizzle. Hold on. Component swizzle identity. Cool. And we'll just do that again for R, G, B, and A. Don't know if that'll fix that problem, but it's something. What are these values by default? Just 0. Okay. It's probably not right then. Yeah. Vulcan spec states if a bound pipeline was created without a VK attachment sample count info AMD or attachment count info NV structure, and this feature is not enabled. Multi-sampled render to single sampled feature is not enabled. NVK command begin custom. Oh my god. It's a lot of parameters here. Wait, color attachment counts. Throwing shit at the wall here, but like... I think that's made a problem worse. Yeah, we're gonna not do that. Yeah, sometimes you do gotta throw some shit at the wall. This is true. Oh god, there's a whole bunch of stuff up here. What the fuck? Create graphics pipeline. So, create info, color attachment formats. Did I even do that? Oh, I have color blend states. Where's attachments? VK create graphics pipelines. Create infos. Okay. Color attachment formats. There's only color blend state. I don't know what it's referring to here. Or, oh, does it mean this? It probably means that. P-color attachment formats 2. Ah. Does not fall within the begin-end range of the VK4 enumeration tokens and is not an extension added token. Wait, why are you reading 2? That would be the third item. Oh, you're reading a bunch of these. Oh, okay, hold on. I think I just, like, caused a problem for myself by accident. So let me... Okay, yeah, that was because I did some goofy nonsense and did a bunch of stuff I wasn't supposed to. Cool, I'll ignore that now. Let's have a look at this. This is specifically on VK command draw. Image views, image views, image views. There's only so many spots here where the image views are even referenced, so it has to be around here that I'm causing a problem. Base MIP level, level count, aspect mask. Yeah. Not giving me a whole lot here, I'll admit. Image sample counts. Where's... Would be in formats? Well, that looks closer to what I'm looking for. No, we ignore everything that's not BGRA. Interesting. When we're looking for, yeah, physical device surface formats. Let me create the swap chain. Format color space, array layers. Well, like, hold on. So if it's 1 it's looking for anyways, what if I just give it 1? Or, more specifically, sample count 1 bits. Oh my god! Oh my god! Triangle! It's not rescaling, but that is perfectly fine. That is not a problem I'm fixing right now. We do still have some complaints here about semaphore usage. That's definitely going to need to be fixed. But, like, look at triangle! Oh, that's so cool. We finally made it, and it only took way too fucking long. Delightful. Ah, look at that. That is so horribly broken. Oh my god. Oh, right, because we created a bunch of new stuff that I haven't actually taken the time to destroy properly yet. I'll quickly tack those on. As I create the graphics pipeline, which includes the shaders. VK... command pool, I guess. Can I just destroy the command pool? Yeah, VK destroy command pool. I'll at least make this not as upset at me. Slates. VK, command pool, no allocator. And that can't return. Yeah, that's not gonna return anything bad. Awesome. Command pool. We're surely going to do something about the buffer as well. Or not. Oh, right. Buffer's destroyed along with the pool, so it doesn't matter. And our sink objects we need to get rid of. How do we want to handle this? Render finished. VK destroy semaphore, and that's going to be render finished. So we have render finished. We have I do not remember what it's called at all. Present complete. And we'll just, destroy that as well. Nope, that's not what I want to do. VK draw fence. We will then destroy the fence. There we go. Hopefully that's a little bit tidier. Well, it complains less. Oh, it's in use by a VK queue. So... That's query pool. Destroy query pool. No, I'm looking for queue. Okay, no such thing. That's interesting. Oh wait, command buffer is in use. Okay, well you have to tell it to stop being in use, right? Big intro command pool. Free command buffers, I guess? Right, because it would be like... Command pool, command buffer counts. Yeah. VK command pool. Cool. And that null is unnecessary. Yeah. Okay, maybe it stops complaining about that then. No, it's... Yeah, because it's in pending states. Okay, I'll have to figure that out later. Dealing with that queue is going to be interesting. All submitted batches that refer to semaphore. Okay, yeah, there's definitely like proper cleanup stuff that I haven't covered yet. So that was hopefully going to be covered in this. I don't know. Actually, I can probably do like I don't know, create fence. Could be some API reference for that, right? Any day. Maybe you can find that for me? Yeah, VK create fence. Oops. VK create fence. Okay. No results. Oh. Yeah, not in this components. What are you talking about? VK create fence. Here we are. I guess I can... Yeah, I'll work that out later. VK pipeline has not been destroyed. That'd be here probably. Yep. Destroy pipeline, slates, VK pipeline. Whoops, no, VK device. And then slates VK pipeline. And we have no allocator. No custom one. Cool. Trash the pipeline. I think that got rid of that particular error, so that's nice. Yeah, fence is currently in use. All queue submission commands that refer to a fence must have completed execution. Okay. I mean, I guess I can wait for them. That could actually work. Let's do fence count, and then slates VK draw fence. Get a pointer to that. And VK true, timeouts, UN 64 max. This one. And we will now have to wrap that in this. Let's see if that just gets rid of the fence problem. Oh, for God's sake. C. Your language servers are something else sometimes. Okay, let's see if that fixes the fences problem. It does! How delightful. So I think I can just wait for... Actually, yeah, it doesn't complain nearly as much about the semaphore. Yeah, it just says it's in use. So I guess we have to wait for queue? Oh, hold on. Oh, VK wait semaphores. Hey, there it is. Oh, wait info. Great. Do we even do any of that up here? Semaphore wait info. We don't. I feel like we should be doing that. Huh. C and LSPs are something, yeah. All right. Uh-huh. Wait info. UN 64. Max, once again. Semaphore wait info. Spending 3 hours the other day unsuccessfully trying to get a build system to just give me a damn compilation database for me, ClangD. Oh, yeah. My favorite. Semaphore count. Oh, I guess we just wait on both of them, right? Yeah, no, we'll just do the one here. Because I don't have them chained and I don't feel like dick around with that right now. Well, actually no, because this is single threaded, so like this would totally work, I think. Uh... Yeah. So we'll do... it's just a pointer to semaphores. Yep. Semaphores. 2. That's going to contain Slate's VK present complete and render finished. Cool. What else could you possibly need? Flags. What flags do you have? Wait, any? I think these are fine, right? Surely. Okay, well, it waited politely. All elements of P semaphores reference a semaphore that was created with a semaphore type pipeline or timeline. Oh, so I don't want to wait on these. P-values must be a valid pointer to an array of semaphore counts U and 64T values. What? Okay. Okay, yeah, tell you what, I'm gonna leave this as it was a moment ago. Because it was mostly just complaining that it was like the queue was still in use. But I reckon if I were to properly close the queue, then there wouldn't be a problem. Yeah, like, see, it only complained with one of them, so this is a weird timing issue. These two things are also weird. I'm gonna read that properly later. This is still a really good spot, though. Pretty good spot to fucking close off, am I right, baby? Yeah! Oh yeah, we did some fixes with the audio today. I completely forgot about that. Let me just diff that real quick. Yep. Git add, git commits. Fixed, broken, tuning. I'll say your tuning. Okay. Oh yeah, all of that. Okay, there's a lot of chunks here. Hold on. Actually, wait, can I just do this? Quit, do not say, just hunker any of the remaining one. Oh, yeah, okay. Fix debug flag. Cool. Yup. Looks good. That's... oh yeah, that was intended. Fix those, yup. Uh-huh. Yeah. All looks fine by me. Alright. I'm not going to stage that. Oh, yeah, I'm gonna have to do that. Whatever. Lots and lots of changes there. And an Vulcan. Yup. All right. Triangle percent, baby. Vulcan triangle percents. Good hustle. Good fucking hustle. Right. Oh my god. I am up way later than I should be. But we have triangle. That's extremely awesome. Actually, I'm going to pull it up again because of how excited I am about this triangle. 1 second. Here. Triangle! Hooray! Oh, I'm delighted. That's so good. Fantastic. And look, the errors fit on my screen. It's basically 2 errors. I think solving one will naturally solve the other. This seems to be like a weird queue-related issue. And that is also queue-related. So I think if I'm just like waiting on queues properly, that'll be fine. We'll be good. Just the validator complaining. It's doing its job. The triangle still renders. Right. And on that delightful note, it is time for me to go to bed. I need it. Everyone, I hope you enjoyed this. We've been going for 6 hours. Okay, Saturday's stream is going to be interesting, isn't it? Turns out Ari coding is good background noise for coding. Didn't even notice the time gods. Yep, that sounds about right. Right. I'm gonna send off on... Do I send off on a raid? How tired are we? Is that even worth it? I'm so tired. You know what? Someone else is doing game development. 2 people are doing game development. Yeah, you know what? We're gonna shoot over to someone else doing game development. Fuck it, bro. Fuck it, bro. Yeah, some of us going to bed. I'm certainly going to bed. I'm just gonna like raid and leave. But I do recommend stick around for this one because this one looks interesting. They're working in Godot, I think. That looks like Godot. Making my first game in 1 summer. Hell yeah, that sounds awesome. Yeah, we're gonna go to Pushpin Bird. That's who we're gonna go to. Godot. All right, everyone. Thank you so much for stopping by. As always, I hope you had a good time. I hope you have a lovely rest of your morning, afternoon, or evening, wherever it is you hail from. And that is all for me for tonight. Have a good one. Bye.